Hey there, folks. So, last episode we finished up our harvest actor, or harvestable actor. We set up this mushroom to represent those. Get to the point where, there we go. So we can pick that up, the collision disappears, the text drops off, and everything like that. And as promised, this episode we are going to start working on our inventory system. Now, with that, this first episode is going to be a little bit more on the classroom side than anything. It's hard to explain, but we do need to go through and cover some of the basics of how we want to set up our inventory system. So I've gone through and provided a slide almost here. It's actually just a simple file that covers the sort of resultant class structure that we're going to be wanting to use for setting up our inventory. And just to expand on this, and you'll probably notice there's typos or something in here. This is just for me and to show you guys. But anyways, to run through the whole purpose of this. So this is the class hierarchy that we're going to want to be using to represent the various different items in the world. And this is a fairly basic setup. I wanted to try and keep this as limited as possible, but at the same time keep things separated as they need to be. So just going to run through some of the basics here. So the first thing, everything is going to start with, let's change this to a blue pen, with item base. That is going to be the parent class, and that's actually going to be I can't write with a mouse. That's going to derive from a U object. But anyways, get rid of that. We don't need that up here. So every single inventory item is going to start from an item base, and then they are going to go off in, well, two different directions from there. You're going to have your equipable stuff. That's like your clothing, your weapons, anything that gets used on a character and has a visual representation on a character that's not just playing an animation. I wanted to clarify that because some of these you could have a visual representation through an animation. But anyways, so that is going to be our equipable items. Equipable items now then derive into two different types, and that is, they're pretty self-explanatory. They're your clothing items and then handheld items. And that's things that the player will have the ability to hold, or the character, I should say, because this also extends to NPCs and the like. So we have handheld items. That's things like knives or guns. Weapons in general. You could also expand that to include things like, depending on your setting, binoculars, similar items like that. Then we have our non-equipable items. Now, I didn't really color code this one right. This particular non-equipable should actually be color coded the same as item base, because I wanted to do that for purposes of this. But at the same time, it's not a big deal. So non-equipable is anything that goes into the inventory, but you're not going to want to have the ability to show it on the player character or an NPC. So that's going to be things like a bottle of water they picked up, stuff like that. Now there's some games like, trying to think, Project Zomboid. That's one where you can put a lot of stuff as like in your hand, things like that, even though you've got zero use, and there is visual assets for that. So that's going to be down to the style of game you're looking for, because ultimately I intend to do a first person or true first person camera. I've divided these out in this way. So non-equipable, the first one I'll cover is resource. Now that is things like ammunition. If you notice, that's why there is the dotted arrows pointing to the handheld items. And that's because these two items are going to need to understand or know about resource. And then the next thing you've got is junk. Those are items that have zero practical use for the character directly. A good example of this is Fallout 4 and all the junk that you scavenge for construction purposes. So like you pick up that desk fan, that the desk fan itself has no use, but it's got a bunch of components, unless you want to decorate, that is. And finally, it breaks down to consumable. And then consumable are your what you would expect. It's things like food, water, and medical. Now, these are very broad categories. I've done that again intentionally to try and help simplify this process. But anyways, I'm going to remove that blue circle. So now with that, you do need to try and think, okay, what information are we going to need for each of these? And do we need any of the lower level items to know about it? So, well, first thing, every single item is going to have a name. So actually, I'm going to do this right here. Put yellow there. Every single item is going to have a description, an icon, a weight, and a max stack size. Now, the stack size, I will clarify, we are going to be handling that the actual stack size within the inventory component, not on the item. Okay, well, condition. Do we need every single item to have a condition? And this is not a trick question or anything like that. That's going to be down to your game. Well, in my setup, no, I don't need every single item to have a condition. I only want equipable items to have a condition. Damage, well, that is things like damaging enemies. So I'm going to put that down here on these. Handedness. So now that is a very weird word, and I'm not sure why I use that, but that is it a one-handed? Is it two-handed? Can it be off-handed? So that is going to be something that you're going to want for your handheld items. Protection. Okay, well, that is for your clothing. Resource tags. Now that is going back to, as I mentioned in Fallout 4, how your desk fan has springs and screws and all the other funky stuff in there. Well, that's something, actually, I want every, can I get rid of that orange? Yes, I want every resource to have. So let's just do that. Equipable slots. Well, that is something for equipable. So let's go here. Every single object is going to have a world mesh, because that's going to be something that represents your pickup, world pickup. And then finally, stat adjustment. Well, that one, again, my wording there wasn't the best. That is for your resource items, your food, water, medical, consumable. No, that purple just ruins that. Well, I'm just going to do it this way. So right there, that's a very, very high level breakdown of the information you want and how it's going to be stored. But you're going to notice there's three objects, or sorry, class definitions here that don't have any information. Well, that's the whole purpose of why I've color coded those green. Green are a final class that can be used for representing a actual blueprintable class. So the light blue was that. So what I'm doing here is, you can just see, I'm like, okay, well, you can't see me pointing at my screen here, but you can see that melee and ranged both had the damage attribute, and that went, well, they're both there, so they're derived from handheld, so we'll just move that up to handheld. So there is a couple that you do obviously need some sort of unique, because you don't want handheld like weapons, things like that, to have a protection level. So obviously you need to derive from that to create your clothing. Resource, if you notice, there is nothing coming from item base. So what you can actually do there, and this is all part of like the planning your inventory system. And I was actually going to skip all of this, but I thought, no, this is actually useful for teaching and, well, not really teaching, but explaining. So here you can see, well, resource doesn't need to actually derive from a non-equipable class because, well, non-equipable has nothing unique to it. Consumable doesn't need to, and junk doesn't need to. So ultimately what we've done there is, well, we've trimmed out this one, so we don't need non-equipable. And we've, instead of having to, well, actually no, there's going to be more to these, the weapon section, but we'll be covering that on the episode I go into weapons. But so this is just a really very basic rough breakdown, and something I would recommend you do for your own inventory system. Start like this. Okay, so you have item base. What information is every single item in the game going to share? Like, and not have the same of, but the same parameter. So like we've got the name, the description, the icon, the weight, stack size, any resource tags. In this case, that's unique to my setup, the world mesh. And that is going to be, like, every single item has that information, so it goes onto this item base. Okay, so how do we fork that to cover the rest of the information? So we have the equipables. So that is the equipment slot, the condition, handedness. You could put in here, but really because it's unique to the actual handheld items, it goes down into a handheld class. So on and so forth. Now, covered that first 10 minutes of classroom in here. Let's hop into the editor and create our first one. We're going to start with our item base. So I have the editor open already. Am I playing an editor? No, I'm not. Okay. So I've got the editor open already. I'm just going to pull over the content window. In our C++ classes, go into your project and your public. Now, one thing, this is with our file organization. This is something that's going to differ slightly because, let me just bring this back up, because we're going to have right now, what, 1, 2, 3, 4, 5, 6, 7 or 8 classes. I'm just going to actually round it up to a nice simple 10 C++ classes that are all around items. I actually want to put this in its own folder. So you come through C++, your project, public, right click, new C++ class, all classes, because you want UObject. You don't want none because that's not a UObject. That is just an empty file, and I don't believe UObject is actually in this list. So let's just quickly check. No, it's not. So you come over to your all classes option, and the very first one, if you notice, everything else derives from a UObject. This is the most basic object in Unreal Engine, or sorry, basic class in Unreal Engine. And we're going to call this one item base, and then we're going to put this in a items folder. I'm going to create that class, and you can see here it is the utmost of basic classes. It's actually really a data class. It's not a placeable object or anything like that. So from that, so we've got item base, and we're going to just work on that this episode. So minimize this, go back to the editor, and it's still doing its thing. So we can just stay in Visual Studio for now. So just for everyone's reference, I'm actually going to have this off to one side of the screen, and I'm going to just do some basic work from that. All right, so I'm going to reload the project. And it's being slow. Typical. Oh, that's because it's also doing the live code. I'm going to cancel out of that. It's canceled. And actually, we don't need the editor open, so I'm going to close. It's still doing its thing. That's probably why everything's laggy. Well, I will pause right here, and I'll be back as soon as this has finished taking its sweet time. All right. Right, so it's finished taking its sweet time, and I've closed out of the editor because we don't need to be in there for right now. So what we're going to do is we're going to go into our item-based header file. Now with this, we still need to pay attention to class hierarchy, parent-derived classes, things like that. And we need to, well, we don't want anything to be private because that means it's locked to this particular class. What we actually want is these to all be protected. So we're just going to go protected. Helps if I could spell. And then for ease, let's see, do we have a decorator visible anywhere? We want an edit defaults only. Well, I'm just going to grab this one here. And we're going to go back to our item base. Put that down, edit defaults only, blueprint read only, category meta. Don't need category on this one, and we don't need save game. So I'm going to copy that because it's going to be the one we're going to be using. So the first thing, as mentioned, is we're going to have a name for everything. Now with that, you could just use fname item name. Problem with that is an fname is not by default multilingual. It's whatever it's defined and it stays as that. So what we want to use here is ftext item name, and then ftext item description, and then texture 2D pointer icon. This is also could be your thumbnail. It is the visual representation of the item in your inventory. Now, in some cases, again, we'll take Fallout for example. It doesn't have a unique icon. They fall under a category and they just have a name. That can work as well. That is entirely up to how you want your inventory system to be. And that's why we use that diagram and say, okay, well, everything's going to have an icon. But anyways, so next one is going to be an int, and this is max stack size. And that one we're going to actually give a default value of 1. Now with stack size, there's a couple of different ways you can go about it. Because, in my personal choice, I've looked through, watched a couple of different inventory tutorials online. There's a couple of different ways. Some people will say, okay, let's put a bool can be stacked equals false. Well, you got 2 bits of information that can, sorry, 2 variables that can be used to define the exact same thing in there. That's just an IntelliSense error. You have this, which is saying, well, no, you can't have more than 1. And like some people would have, okay, it can be stacked up to 5, so we need this to be true. Well, you don't need this. It's quite a simple case of, if your max stack size is greater than 1, it can be stacked. So we don't need any additional variables to define can it be stacked. Yes, it could help with expediency, like going through and parsing your inventory to see, can I put something on the stack? It may help there in a like nanosecond degree in efficiency, but the let's say again, I'm just going to type, so if item dot can be stacked versus if item dot max stack size greater than 1. Both of those, like this here, we're talking there's one additional, in theory, might be more than one additional CPU cycle to calculate this versus this. And bear in mind, a CPU cycle is measured in like nanoseconds. Like it's insanely fast. So ultimately, this may be slightly slower, but it's imperceptible. And unless you're trying to multi-thread multiple inventories at the same time, you're not going to see the impact of this. So anyways, next thing we need to add is resource tags. So now we need to, right now I'm just going to do this, ftext, actually, tarray, ftext, resource tags. And I'll cover those in a moment here. And then finally, you have static mesh. Now this is a static mesh, not a static mesh component, because we are just wanting to point to a static mesh to say this is what the world object is going to be. Now some of these are probably going to need to be T subclass of. I'm pretty sure this one here, but we will cover that in a moment here. And ultimately, this is all the basic information you need. And again, it's going to be dependent on your game and your inventory system, but ultimately, this is all the information you're going to need on your UItem base. Like, this is every single item in the game is going to contain this information. There's going to be additional information unique to certain types, but everything, your weapons, your equipment, your consumables, your useless pickup junk, all of it's going to have this information. So, what we need to do though is we need to cover resource tags quickly. So resource tags are, and I'm going to keep using it as it's a perfect example because it's exactly what it is. In, say, Fallout, you have things like your desk fan, your random world items that represent or that contain multiple sub-objects for, say, crafting. Your fan has your wires, your motor, your screws, things like that. And what they are is items that can be salvaged from breaking apart something else. In the game I'm intending to create, I want that functionality. So that's what my resource tags are to represent. What we need there is a way to actually represent that. Well, we've already covered that in what we're going to be using in a couple other episodes, but we want to use struct. So struct, how do we want to call this? And I'm actually going to change the name resource tags because it's not the correct salvage item. So F salvage items or item. So generated struct body, and these we want to be public. I'm just copying that. We don't need the meta allow private access. So what we want is an int quantity equals 1 just for default. Now, this is where it gets interesting. You can use a couple of different ways to go about this. You can use, say, a text, item, string, whatever, as just a pure representation of this item can be salvaged for 5 copper. And then you would just go ftext in here. And again, you'd want to use text because that 5 copper, you want the word copper to be translatable into whatever languages your game supports. Call that tag. Or the other thing you could do, and this is more specifically if, say, you want the item to break down into other items, which is how Fallout does it. You would go uitem base pointer. I think that's a T subclass of, again, item. And the way I want to do this is actually using this, because I don't want to say this fan is worth 5 copper, you use 3 and it's gone. I want it to be, okay, the fan is worth 5 copper, you break it down and you get the 5 copper. Fallout sort of does it in the middle ground. It's like, okay, this fan is worth 5 copper, you have no other copper available, we're going to automatically break it down and give you 5 copper, but you needed to use 3 of that to build whatever. We're going to take that away so that you're left with 2 copper in your workbench. I don't want that. I want the... I understand it could be an annoyance for players, but I want that required intermediary step of this item needs to be broken down, and then you're going to get this as a result. So I'm actually going to remove that. And yes, this does need to be T subclass. T subclass of why are you throwing? It's there. IntelliSense is just being slow. So what this is here, what are you saying? You cannot expose properties to blueprints in a struct that is not a blueprint. Oh, I missed that up here. So yes, when you create your uStruct decorator, you need to include the blueprint type, obviously. Again, you want to try and expose as much of this to blueprints as possible, simply because, yes, you may be writing in code, but you could have somebody who's not writing in code, they're working in blueprints, because it's 2 very different skill sets to work between the blueprints and C++. I'm not saying a C++ developer can't work in blueprints. I'm not saying somebody who specializes in blueprints can't work in C++. It's just you need different skill sets to work with them. So anyways, we now have this struct here, F salvage item. We're actually going to put that in here, and I'm going to actually just quickly go T subclass of, and so just for clarity, this T subclass of, the reason for that is you're pointing to a class reference instead of a world object reference. So we've got that there. Let's just do a quick build. I'm actually going to try and start shortening my episodes to around 30 minutes instead of 45. Simple reason being is most people sort of stop watching after 30 minutes on my videos. And I understand 45 minutes to an hour is a pretty long chunk to sit when you're looking for one bit of information. So okay, that build is completed. So we're just going to launch into the editor quickly and just see if we can actually use this. And if we can, what we're going to be able to do with it. And from there, that should pretty much be this episode. I understand it's a little short, doesn't cover everything people are expecting in an inventory system, but it is the beginning. So, all right, we're in the editor. Actually, it's pretty quick. We're going to just go through quickly into our content folder and our, when this decides to work, and our projects file folder even. There we go. Open up a project, into our blueprints. We're going to go into our dev blueprints again, and let's go item base. Oh, well, it's not there. I wonder why. Is it because I can't type? Let's just put item. Oh, that's because it's a U object. So, just show you here, we're going to go into our items, create a class from this, and then we'll go to our base class, create a class, create a blueprint actor. So the whole purpose for that, and yes, shamefully I did this on purpose, is there needs to be a, I think it's blueprintable. I think that's the tag, the decorator that you need to add. Quickly check that. Move you out of the way. And we'll just see, was that enough to be able to do a live compile? Building tag, yeah, it looks like it. So. U objects, because they are not intended to be in the game, like actually in the editor, used in the editor, they need that decorator. And I'm like 95% sure that is the decorator we needed to use. So, or attribute in the decorator. I correct myself there. Let's see, was that the one item? There we go. So you need to add that in there to then, like that attribute to the decorator, to be able to access it through the editor. This is just so we can do some basic testing. It is not something we're going to do. I'm actually going to be removing that tag. That goes back to here where you've got the green items versus the other items. The green ones are ones that are going to be blueprintable. Green classes, I should say. The other classes are not going to be, because they are purely logic classes that we're deriving from. So let's move you back out of the way. And I'm not even going to name it, because we're deleting this right away. So I'm just going to pull this over. And you can now see in here we have a name, an item description, an icon, max stack. We have the ability to, well, there's nothing in there right now, because I don't think you can, why is that not, that should have new blueprint as an option, but for some reason it's not. Let's see. No, I have to move this over to one side so I can get, I'll have to look into that one. I'm not sure, but we're still a little ways away from needing this. But anyways, so just open this up. So yeah, you can see you have our item name, our description, our icon, our stack size, our resource tags, and our world mesh. In the world mesh, you can see, oh, okay, that didn't need subclass of. Or did it? Let's fix that, and we'll go back in and do another live code compile. But yeah, anyways, while this is going through, I'll just run through the basics, because this is just some cleanup. I want to, well, make sure it's working before we wrap up the episode. Okay, live code compile worked. Okay, so yeah, that was the issue. It wasn't T subclass of. It was just the U static mesh pointer. And literally all this is going to be used is to reference the static mesh that we need to use to create our, where is it in here? Pickup actor. That's all that is. So like if you drop something out of your inventory, you're not going to be dropping this. You're actually going to be dropping a pickup actor. That's going to be what's on the floor. That's what you're going to be picking up. And this is going to reference one of those items, like the item base for the information. So, yeah. Anyways, folks, so that is where we're going to end this episode. This probably actually doesn't need to be T subclass of it either. Let's just fix that. I hate leaving things unfinished, so do that. And one final live code recompile. Yeah. So, anyways, with that, as you guys can guess, these 30-minute episodes mean the inventory system is going to be broken down a lot further into smaller sections. However, that is actually what I intend and I want, because I want to cover each of these classes individually. And yeah, that wasn't subclass of either. So we'll be fixing that in another episode, though. This was just getting the basics set up. So with that, though, folks, as I said, we are going to end the episode here. Right now, we have covered item base. And as we went through and I intentionally did this to explain it to you guys, we narrowed these down to, these are the next derived class. We got rid of non-equipable. Next episode, we're probably going to work on our equipable. And I want to work, because I want to focus on like one branch at a time. But anyways, thank you, folks. Hopefully this has been helpful to you. As always, any comments, questions, concerns, feel free to throw them in the comments below. And with that, thanks for watching, and I will see you in the next episode. Hey there, folks. So, last episode we started off our inventory system by creating our basic UItem class, which is going to be used to define all of our core logic for all inventory items. This episode we're going to be moving things a little further forward. So in here you can see this is the one we went through, and I removed all the highlighting, but we went through and determined, well, we no longer need this non-equipable intermediate class. We can go straight through from our item base through to our other three. Now, with that, we did establish also in last episode that our item base, our equipable, our handheld, and our consumable in this case are classes that they themselves are not going to be blueprintable. We did throw that in there, as you can see right here, as a way to test within the engine. But really the main focus of these classes are going to be just, item base, equipable, handheld, and consumable are going to be for data and logic, where the more specific ones are actually going to be the blueprints. So what we're going to set up this episode, just because it's something to keep things moving and keep things in, well, partially in the editor, we're actually going to work on this junk class. This one is very basic. It has no direct use for the player character. Like, it's not something they can wear, it's not something they can wield, it's not something they can consume. But this is going to represent things like, as I was using in the last episode in Fallout 4, you have things like the desk fans that you can pick up that to the character directly have zero use, but they're usable for the parts that they contain. So we're going to start in this junk class, because that's actually going to be the class that is going to be used for, let's get this out of the way, all of these salvage item information. Because your player, well, maybe in your game you might want to, but in my game, and sorry, that wasn't meant to be condescending. I understand robot games, things like that, but you're not going to want your player to eat things like springs, copper wiring, circuit boards, stuff like that. Again, as I was just saying, we could have a robot game where that's a resource. In my game, it's not. So that junk class is going to be where this information comes from. So that's going to be your copper, that's going to be your circuits, your iron, things like that. So also, I just want to confirm I did go through and I updated, validated that T subclass of is actually the correct use there. I'm not sure why the editor, I didn't like it. I think it was because that was a live code change, and that they don't always work. So that is something else I can recommend, as I found with Unreal Engine, is though you may be using a live code update, doesn't always work. So with that though, folks, I'm going to just quickly build the engine just to show you. It should be all built. I say that and it's creating files. I don't think I changed anything since the last time I built. Oh, there we go. 5 succeeded. Must be something with... Oh, configuration stuff. Anyway, so we'll launch the editor quickly. And we're just going to go through and create a new class. And this one's actually going to be really quick. We're probably going to start branching into one of the other classes, because I just realized there's almost nothing we need to do to this. So now, while this launches, one thing I know I did say this is going to be using the junk object type. but we have it listed as uitem base. Now there is potentially going to be some situations where you want things that are salvageable into non-junk components. Um, just trying to think what we could have there. Off the top of my head, I can't even think of an example, but I know there was a reason. I thought about this for quite some time before I decided how to lay out those classes, and I know there was a reason I wanted the how salvage items to be, well, to use the uitem base, because then it could be anything. Like technically using uitem base, you could have something harvest into a higher level. So you could have a iron tube harvest into a gun, if you wanted to. I'm just trying to think now. Actually, I can't justify any reason why. So we'll actually probably fix that in this episode as well. But anyways, the editor is taking quite some time to load up for some reason. So I'm going to pause the video and I'll be back as soon as it's ready. Alright, so we're back in the editor here. I'm just going to pull over the content browser. Go into our C++, our project, public, and because we're working in this new folder location, items, open that up. Now here we're going to right click on the item base and we're going to create a C++ class derived. And I'm just going to call this junk item base. And everything else is still left as is. The path you want to keep in items, and the header and source file are automatically put into the public and private for you because we have the class type. So with that, I'm not quite sure. I thought I could do a full episode on this because literally this is it. There's two changes we're going to be making here. So the first one is going to be blueprint. It's what we have in item base. Blueprintable? Yeah, blueprintable. It's being slow because it's still running everything, but I'm trying to keep things moving. So the junk type, or junk class, again, just while this is running in the background, I'll pull this over. So this junk class is literally, it's for all of the, well, junk objects in the world. That's why I use the term junk for the name. It's for everything that does not have a specific use to the characters, be it player or NPC, but it does have a wider use overall. So that's things like nails. Well, nails do potentially have some use depending how you think about it, but nails, boards, as I mentioned, wire, circuitry, things like that. And all of that is, they're just something that doesn't have a singular use on its own. Now, I know we do have what I've called a resource item, but that's things like bullets, or fuel for, let's say, a chainsaw. I was just trying to justify why I have this line for melee. And that's what these lines here represent. It's like this is an end result class that these know about. That's why they have the dotted line instead of the solid line. And melee, not so much. I put that there for the potential of, say, a chainsaw because it needs fuel. But you've got things like ammunition. So the ranged would need a resource of ammunition. When actually I'm going to have that double, it's going to be a circular thing here. So my intent is ranged, depending on the weapon, are going to have a magazine. The magazine is then going to have ammunition. And I'm sorry if I'm using the wrong terms for all the gun aficionados out there. I'm not a gun enthusiast, so I can never remember if it's magazine or if it's clip or whatever the terms are used. So I do apologize if I'm using the wrong ones there. So anyway, so with that, there we go. This is now, yeah, we can stop debugging because we haven't done anything there. So we are going to do two other changes though. I was just thinking about it. So we need to grab this include from the source for junk items. And we're going to throw that in the source for our item base. No, what are we doing? We don't need to do that. Or do we? No, we don't. Item base, so we are actually going to change this to U junk item. And the whole reason for that is I cannot think of a reason. Windows Defender is still running, isn't it? Yes, that is why. And it is not letting me save for whatever reason. Because it's still scanning files. Well, anyways, while this is doing its BS in the background. So we can remove this blueprintable from our UItem base because we no longer want to be able to create blueprints. There we go, we can save finally. And the reason why I decided to change my mind on this is I genuinely cannot think of a reason to allow things to scrap down to something other than this. Now, should that ever happen, it's actually a very easy fix. Literally, because junk item is derived from item base, all we would need to do, we would do, come on, right button, junk, and then that would fix it. You wouldn't need to update any of your blueprints or anything like that you may have done, because unless you're wanting to add additional salvage items, obviously, but you're not going to need to fix any of your blueprints. That is still going to work. But for now, I want to leave it as a junk item because I want to leave that restriction in place. And I just realized I missed some properties from here. So, a couple other things that we know every single item we're going to have. And this is actually a big one. And now this is actually going to be dependent on how your game is going to be set up for carry capacity. But in my case, I do want an item weight. What is it? There's another one. Clamp? No. Oh, let me find this here. It is clamp min. IntelliSense just wasn't pulling it up. Property though. So this is, again, I mentioned in a couple of other episodes where you've seen me doing this. It's a lot of what programming is. You're literally just sitting here going, oh, what's this? What's the answer to this? What's the answer to this? And that, sadly, or fortunately, is actually quite a lot of programming. But anyway, so what we've done here, just to explain. So I've added in a U property. It's edit default only. Obviously, that means you just can only edit the blueprint. You can't edit it at runtime. Blueprint read only. Meta allow private access is true because this is a protected class. The reason being is we want all child classes to still be able to work with these. Otherwise, if as soon as we created, say, a junk item, these wouldn't be available to it. So we need that allow private access with protected. Otherwise, it throws errors. And what I've done here is clamp to minimum. And that's simply because you do not want an item to have a negative weight, because then carrying it would mean it's easier. Now, I understand you could have things like, there was a little thing I seen on the internet not long ago. Somebody had a helium balloon tied to their, and I'm talking a decent size one, helium balloon tied to their backpack, and that would work. But for situations like that, you would want to create, if you wanted to include that, you'd want to provide, do that as something else. You'd want that to have some other form of logic to generate the negative weight that that's doing. So you'd want the balloon itself to have, say, a weight of 10, but then when it's equipped, it would have a weight offset as an attribute or a side effect, like you've seen things. I'm thinking games at this point like WoW or well, even Fallout, where you'd put on the legendary breastplate or chest piece, and all of a sudden it's giving you damage to mutants, something like that. So we've got that set up there. We've changed that over to the U junk. So with that, the next thing we're going to do is I'm just going to move around this in a clockwise pattern. We're going to start on our consumables. So with that, we're going to just do a quick build here. And this one might take a little bit because we have done some changes. There you go, it's building 6 items. So I will pause the video, and as soon as the build is done, I will be back. Alright, so we're in the editor now. Build finished fine, no issues. Apparently my content browser doesn't want to move though. So the next item we're going to do is, as I mentioned, the consumable. This consumable, just the base one. And then from there, we'll start adding some actual functionality in. So with that though, from our graph, we established this is going to derive from an item base. So create a item base, or C++ class derived from. Why are you being so slow today? I'm going to reload. And it is doing the live code. We can just say yes to that. So we've now got our 2 derived classes, the junk item base. We can close out of this one. As I mentioned, it has 0 further code requirements. Literally, it's a here's some items. The reason why we are not using just this pure item base for that is we want to make sure, trying to think how to explain this in terms that it's going to make sense to somebody who doesn't have my brain. If for whatever reason you need to make some changes to those junk items, like you want to, again, I'll use examples from last episode, Project Zomboid, you can equip pretty much everything in your hands, even though it may have 0 physical use. Say partway down the line, you decide you want to, and by partway down the line, I mean through the development timeline. Partway through the development timeline, you decide junk items are going to now have this additional feature that they didn't have before. And instead of having to go through this whole, okay, well, we need to reparent them over here, you have the alternate option of you just start adding to the junk item. But again, as I was explaining last episode, the non-green classes, again, not non-equipable, we remove that one from being needed. But the non-green ones are classes you do not want to directly create blueprints of, because they are nothing but data or background logic. And you want the green ones to be the ones that are actually ones you create instances of with blueprints. So, all right. So, with the consumable, you do have a couple of options there. You could go through and I'm trying to think how to. Trying to think what this you want to do for this. So Anyway, so you okay, sorry, I was just thinking how I'm trying to remember how I designed this in my head. So with that, right now this is all just going to be sort of gray box code, but you could have something like enum stat affected float amount. And what that would be is you'd say, okay, this item is going to affect your hunger and it's going to give you 50 hunger back. It's going to affect your thirst. It's going to give you 50 thirst back, and so on and so forth. And just with that component, stat line component, that would be these guys here, core stat. Now, there is different ways you could go about it. As with the graph here, let's pull this back up. We have different ones. You have food, you have water, you have medical. And I'm thinking about this, and this is why, like I said, it's you want to go through and do a diagram like this, but then you want to actually walk through it a second time, or as some developers will know, what's called rubber duck debugging if you're having problems you can't figure out. Because I'm just sitting here thinking, well, we don't actually need these. This could be the blueprint class here, because like, well, every single one of these is going to have the same base effect. Like when you boil it all down, it's going to be, I'm going to target a particular stat or stats, and we are going to adjust it by an amount. And I'm just thinking, okay, well, do I really need all of these? And the reason why I'm thinking yes, actually, I'm going to remove these because I just realized there's a reason why I did this. These two can become a singular item. Medical is going to be in its own. And I'm thinking for, again, I'm going to use Project Zomboid for anyone familiar with that as an example. Bandages. In that game, they instantly stop a bleed. Where you put a bandage on and your bleeding stops, but it doesn't recover your health, it doesn't adjust anything, so it's a status effect. Whereas food and water are a stat adjustment. So mentally, I was just thinking, yes, that explains it. However, that puts us into another situation where we can just do this and get rid of that one. So again, further things you can do as you're planning these out. I know when I did this graph, I sort of just threw things down. It's like, okay, this will work. So what we're actually going to do is we're going to use the consumable name to represent these two, and then we'll have a medical item, which will be its own thing. But anyways, because I know we're getting close to my new 30-minute timelines, let's get things moving here. So as you can see, we have enum class e core stat. We're actually going to use that. But over here, so what we want is actually something, we've been using these all over the place. So we need a struct. So use struct blueprint type struct f consumable stat adjustment, generated ustruct body, and then these we want, they want these public or private. Well, these can be public because they're not going to be used anywhere else. So u property edit defaults only, blueprint read only, enum class what do we call it? E-core stat. Tells you how good my brain is. E-core stat. Get rid of the first two EC I put in there. Affected stat. U property, we can actually just copy that one. Float amount. Now the reason for this, yeah, actually I'm going to do this in an easier way. I don't want to potentially have missing, well no, because we don't, yeah, it does not need to know about all of this crap. I'll actually probably do that in the next episode, thinking about it. I'm going to do some cleanup. We have a lot of data types that are being, like, I've absentmindedly just thrown them into a class header file when they probably should be in their own data type folder. So bear with me, but anyways, back to this. So we have, no, it doesn't need the semicolon there. eCourse stat not allowed, incomplete type. Let's do, yeah, that is what I thought was going to be the case. I'm going to end up, so everyone knows, I'm going to end up fixing this in the next episode because I do not want to be doing this, but for the sake of moving things along, I will. So we can get rid of that. Why are you now saying you can't? Unable to find class eCourse stat. Don't tell me you can't, because it's right there. I'm going to ignore this one because it's just being a pain because file structure. So what we want here, and the whole purpose for this, is T array, what do we call this? F consumable stat adjustment stat effects. Now what this is for, again, just because it's the only one that's coming to mind off the top of my head, think Project Zomboid, for those familiar with it. You have, or just foods in general. You don't even need to think in video game terms. You can think in real world terms. Like, let's take a watermelon, for example. You're eating that. It's going to provide you with both some cessation to hunger and some cessation to thirst. It's going to fill you up and it's going to give you some fluids. So you're going to want to be able to represent that. You don't want to have to say your watermelon only gives you food or your watermelon only gives you water. So that is the reason for this here. So you could say, okay, it's going to affect your hunger and it's going to affect your thirst. And actually thinking about it, it might be better here for your own sanity and for ease, so you can't accidentally go, oh, it's going to affect your hunger. And you could basically, to stop you from being able to add in hunger like 6 times here and having it all affect them. Actually, I'm going to completely redo what I just did here. So tmap eCourse stat, it's right there. Float. Stat adjustments. And we want to make this private because it's unique to the consumable item. However, U property, edit defaults only, blueprints read only. Oh yeah, and then meta. I hit my cap lock button. So, just to explain this a little though, because I know we mentioned, what was it? Item base, we wanted to clamp that. You don't want to do that with the brain does not want to work. You don't want to do that here with the amount, because let's say, trying to think what would be a good example. Coffee. Not sure most people know, but it's a diuretic and actually makes you thirstier drinking coffee. Your body wastes water to filter out the technically poisonous caffeine. I think that's the reasoning. Again, not a chemist, biologist, whatever. I'm a programmer, so I just know coffee actually makes you dehydrated. But for example, we don't have it in this setup, but let's say you had a stat for energy and obviously stat for thirst and you drank coffee. Well, you want it to give it energy, but you want it to lower your thirst or make you thirstier. So you want your amount to be both positive and negative. I'm trying to think. That would actually be the only property in here, and I do realize I have missed a very important feature. So we've hit the 30-minute mark. However, we're going to add this one feature in, and then we'll carry on in the next episode to start getting some things finished up. And I'm actually going to hopefully remember to add in a couple of like static mesh and icons to use for our junk item. But anyways, what we want to do is go back to our item base, and then we want to add in a public section, virtual void on use, and we want to ATF character. No, that's class ATF character pointer color. I think it's pure virtual. Oh, okay, I'm trying to remember how you define that. UE5 C++ define pure virtual. Helps so I could spell. Pure virtual function or abstract is a virtual function. Yeah, I know that. I want to know how it's defined specifically within a neural engine setup. U function virtual, or are you just saying declare it? There's no oh well, instead of wasting time, I'll dig into that off camera. So what this is here, U function. This is just creating the basic function that if you use an item in your inventory, this is what's going to get called. So just set that up in there. Item base, obviously we don't need to do anything. And the whole reason why I was looking for pure virtual is I wanted to make it so that we had to define it within, like absolutely had to define it here within consumable. But I can just do it this way. Now, also, I would just want to point out quickly before, because we're getting to my timer mark here, we don't need to add in U function blueprint callable here. The reason being is, oh, I just duplicated it instead of saving. You can, but we don't need to because it follows the same decorator information as to its original parent, which would be this one here. What are you saying? Blueprint callable. Oh, I can't spell. Fix that, and then that's probably going to say this doesn't need to be. Yeah, there you go. Override of the U function on use parent U item cannot have a U function declaration above it. It's the same as the original. So, and just get rid of that. So this automatically becomes blueprint callable. So, anyways, folks, we've hit that 35-minute mark in this case. We're going to end things here. Thank you for watching. Next episode, we're going to continue on with the inventory system. I understand we haven't actually started the inventory system itself, but we do need to get the base item information set up. So next episode, as I say, we're going to continue with our consumables, potentially add in our medical, just because that'll be the next one in our rotation, which should have been our first. And I'm going to see if I can track down a couple of items, like assets that we could use to start creating some junk items in the editor. But as always, thank you for watching, folks. Hopefully you've enjoyed and you found something useful. Also, as always, if you have any comments, questions, suggestions, concerns, please feel free to throw them in the comments below. I do try to respond to everything. Thank you again for watching, and we'll see you in the next episode. Hey there, folks. Welcome back. So last episode we did go through and we created our consumable base, we created our junk item, and we added a little bit to our item base class in the form of we added our on-use functionality. There is a couple other things we're going to be adding into this. I realized we missed it. Just quickly though, I just wanted to show I did pull over when my content browser wants to respond. A couple of assets into the project just for the junk items, so we can start creating some samples of those. So we have an ingot, so an iron ingot, copper ingot, a nail, and a box of nails. Now, with that, as I mentioned, we do have a few things I want to add into our item base. Some of them are just really basic functionality. Others are going to be, actually I think the only thing we would need to add right now is our weight ones. So we want to add in a couple of functions here just quickly. Actually, before we get started, I need to close out of the editor. I didn't launch through Visual Studio, I launched through the Epic Launcher just because I wanted to check those assets were present. Close out of that just simply so our live code doesn't potentially cause any build issues. But anyways, so first thing we want to do is U function, float get stack weight with a const int amount, and that's going to be a const. We also want to add in another function, float get item weight. This is going to be a const. Now what we're adding in here, and I'll explain before I go any further, is all of these parameters that we've added that are protected, we have no way of pulling that out for use within the UI. So you're not able to show the name, show the description, the icon, because we've made them protected, because we don't want to be able to start changing them with other code or anything like that. So we need to add, for anyone who's familiar with programming, basically getters. Now some of these might not make perfect sense, but once we get to the inventory component, which will be in a couple episodes, some of these will. Obviously these two here though are not go-to, pretty basic. We're just going to add these in quickly. So this is going to be return weight. What do we actually call that parameter? Item weight. Return item weight. And this one here, now because we're not storing the stack size on the actual item, we're going to be doing that in the inventory component. It's just a item weight times by amount. Now, and these are returning constants because they're non-modifiable. We can't say, oh, well, it's saying the weight's 10, but we actually want it to be 20 or 5. And then we need the same thing for the basic UI. However, instead of having a get name, get description, get icon, what I'm going to do here, use struct blueprint type, struct, was it item sorry, F item UI data. Generated UBody struct. UStruct body, sorry. I'm not talking correct today, it seems. And then we want public, because again, this is just a data class for passing some information around. The other side can technically do what they want with it, but we want uProperty just so it's visible to blueprints, visible anywhere, blueprint read only. And then we want ftext item name, ftext item description, ftext, sorry, item description, and then uTexture2D pointer icon. And then we're going to add a constructor to this. So it's F item UI data constructor. Now, you could, in theory, leave a default constructor, which is just this, and then have another one. However, I don't want to add that. Oh, why am I deleting things? I can just undo it. I don't want to add a default constructor that doesn't have anything. I just want a base constructor that takes 3 items. So ftext, actually, we're not const, ftext reference name, const ftext reference description, and const, actually no, that's a pointer, it can't be, uTexture2D pointer icon. And the reason for that is we are quite literally going to go item name equals name, item description equals description, icon, casing convention, conflict there, lowercase icon in that case. Actually, I'm going to change the parameter because I would rather item icon equals icon. And then we're going to add a function for that. I'm just going to go f item UI data get UI data const, and now we're going to just create these definitions. Well, this definition, item name, item description, icon. Okay, we're just going to build that quickly, make sure all of this is working. In the interest of time, I'm going to pause the video and I will be back once the build is finished. All right, we're back and the build has finished. So with that, let's say we just got this basic get UI data, and that's just going to be for when we get around to hooking up the UI component, which won't be for a few episodes. And just trying to think what else we need to add here. We want to return our resource tags. That's only going to be part of when we harvest the object, but we still want to include that. Get salvage data const. And because these are data classes, actually, we can put this information in the header because these are all very basic. So let's actually do that because we don't really need to add anything in here other than the on use, and even that we can put in the header file. So it's going to do this on use, get item stack weight, return item weight. Don't need that there, and then grab that, and we can just get rid of all of these. And again, the whole reason for doing this is because these are data classes. They're not intended to be like super secure or anything like that, because this is all information that's going to be available to pretty much everything. So we can just do that all in here. Repeating myself, I'm sorry. Return resource tags. And then we also need another one for our world mesh. New static mesh pointer, get world pickup mesh, const return world mesh. So that covers everything we need. Well, actually, no, max stack size. We do need one for that. Where do we want to put that in here? Put that underneath. Yeah, don't need to keep these two organized. Int get max stack. Const return max stack size. Okay, so with that, just covering through this quickly before we move on, what we've done is we have our protected properties that are only going to be exposed to our items and only through their like blueprint editor. They're not going to be exposed anywhere else here. Well, we needed a way to expose them. Well, that's what these are here. Actually, what I'm going to do is just put that like that, because there's the virtual function at the top, which we want to be overriding with all of our classes, or subclasses, I should say. And then we have our functions to get the raw data that we need. Now, these are obviously going to get expanded. So there's going to be, say, for weapons, we're going to be adding in get damage, get things like that. Armor, get equip, get protection, get slot. And let's see, what else do we need to add in here? I think that's everything we need to add to the item base. So we can close out of that for now. Now, in our consumable items, we have our void on use. And what we're going to do is in here, it's going to be for auto. What do we want to call that? Stat. And we named this array stat adjustments. Possible unintended copy is being made. We don't want to do that. For, I'm trying to think how we want to do this. No, that is no, it's T pair. E-core stat int pointer effect. Is that going to work? Do I want references? I think we want references. Reference type, okay, tuple equal int, not const qualified, cannot be tmap base. I'm trying to remember what's the efficient way for doing this. So let's see what it said with for auto. Auto stat adjustment. What was it saying about that? T pair. Oh, it's a float for a start. Because I'm special. So let's go back. No, not. Okay. So that is what I wanted there. This is just for efficiency. So it's actually reference. Yeah, it has to be a reference. The whole purpose of this is instead of creating copies, instead of creating instances for memory efficiency, we're just going to iterate through each one of these. However, caller gets, we're missing our reference to that. So, df character. Grab that, and we're going to go back to our consumable. Add that underneath. We add that in there. Get stat line. We did not. So we want to add that in now. So TF character. Down here in public, U function blueprint callable. You actually just copy that for ease. And this one again, because we're just returning a pointer, stat line. We can use that and declare it in the header. So we'll go back here. Just want to make sure, get stat line. Did we not just define that, or is my typing? Yeah, casing. We want to change this one, because stat line is one word, not two. Now we're going to grab you, and you're going to notice it's going to throw an error. Caller stat. Actually, no, we're just going to call that stat line in lowercase. And it should throw an error about an incomplete data type. Oh, no, sorry, because we have the TF character header reference, and if we look at the TF character source file, we have a stat line. No. Why is that? What? It's not making sense. Save actor. What are we? Oh, we're probably not calling anything. So stat line. This is where it's gonna error out, isn't it? Adjust. Wow, I didn't make this that far. Oh, that long ago, and I'm completely forgetting my function names. What did we call them? We didn't. I swore we added a public accessible function there, because it's there in our adjust tick, get save string, update from save string, percent adjust. Did we not add a public function for that? Obviously not. Private, protected, tick, set movement, get stat. We never added that, so this is on me. So we're going to do this pretty easy though. U function, blueprint callable, void adjust stat, const e core stat reference stat, const float reference amount. And just for the purposes of right now, I'm going to leave that undefined here in the header. So we're going to go back here, adjust stat, effect dot key, effect dot value. So what we've done here is we're relying on the object, the consumable object, to tell the stat line, this is what you're adjusting by. The reason for this, I understand for most cases, especially in like a multiplayer game, you don't want the item to control that. And I want to be clear with that from the start. You want this to be something that's managed on the server and all of that. Cheating, obviously. The reason why I'm doing it within the item itself is I do intend, obviously much further in the progress, I want to add in modding support. Like I want people to be able to add their own items, modify items, and things like that. So with that, I made the decision early on. That's why it's a single player game. Is one, I don't want to deal with multiplayer replication and all of that. Networking, I deal with that actually is one of the main things, is my primary job. Like professional career, I deal with network related work. I hate it. Not because I'm not good at it, it's just, it's a pain. And I just completely noticed something. Sorry to change topic. I'm completely missed our, we do need a default constructor on our item data. So I'm going to quickly fix that. So that's in our item base. But anyway, so what I was saying there is I just don't want to deal with a multiplayer game. Plain and simple. I'm not going to that extent. This is my first game I'm making. You guys can't see me doing air quotes here, but pseudo professionally. And I know I'm already picking a pretty, I'm trying to think of the term here, lofty goal of creating a survival game. And I didn't want to overcomplicate that with the multiplayer aspect. Now, should this be successful? Yeah, maybe. But right now, single player. So, back to the point though, because I am purely looking at this from a single player perspective, and if a single player game, the player wants to cheat, let them. They're going to find ways, and potentially ways that break your game if you're not careful. So, when you're in a situation where the implications of cheating have zero negative effects on anyone but the person cheating, just let them do it. So anyway, so just to go back to where I was saying on here. So on the consumable item, when we call the onUse function, we are getting the stat line of the TF character that called. And they are going to, or it's then going to iterate through each of the predefined stat adjustments that we have added. And it's going to call back to the stat line component, and from there, it's going to make those required adjustments. Anyway, so now that I've realized there was that build error and we've added this in, we're going to run another build quickly. And then if this build succeeds, which I'm hoping it should now, we're actually going to hop into the editor and we'll just start creating some basic junk items just to show people what we created in the last few episodes does work. As I know we only did that very quick debug for the initial item base that we created. But with that, again, in the interest of time, I'm going to pause the video and I'll be back as soon as the build is done and we're back in the editor. Alright, so that build succeeded and we're back in the editor. Just going to bring the content browser over here. So with that, just going to quickly open up our C++ classes so we can take a look. So in our items, we have our three. We have our item base, which is the lowest level. Nothing can be derived from that. We have our consumable item base, which is for things like food and drink. And we have our junk items, which are our resource items. Things like screws, planks, nails, stuff like that that you don't plan on being equipable by the player. I use that because I realized a plank could be equipped as a weapon, actually something I do intend to include. So we are going to go to our project folder, blueprints. No, this time we're not going to use the dev, because we're actually looking at creating something that might be used further down the line. So I'm going to put new folder, items. And then we're going to put a subfolder, junk items. And in here, blueprint class, search junk. Junk item base. Actually, just while we're in here, I want to also say we could do item base. It's still present. Now, hopping back into here, is this just because I missed it? Item base. No, we didn't. So, to explain, you can't actually create it. Don't worry if you see it here. We can do an object, but we can't do an item base, but we can do a junk item base. The reason for this is it shows your class hierarchy here in the browser. So we want to create a junk item though. And I'm going to name this BP copper bar. No, copper base. Copper bar. Simple as that. So you're going to see when we open this up, you can open on this screen or a different one. I can't remember. No, off to the left. So we have our basic setup here. Well, if you notice, it's the exact same as item base. The only thing that on use, we can call that, which is something that in theory you could call an item base if we had defined it. So what we're going to do here to start with, copper bar base. Why do I type that by default? A simple copper bar. We don't have an icon for that yet. I'm going to say these can have a max stack of 10. Now, because this is a resource stat, we don't want to add any resource tags. World mesh. Well, I'm not going to search through that list. I'm going to just move this out of the way quick. That was from my mining fantasy pack. Models, ingots, ingot 7. Bring that back. Put that here. And we're going to say that has a weight of 2.5. And there's a basic item. Now, let's see. Go back to our items. Go new folder, consumable. I think I made a mistake here, and we're going to have to do a live compile. Is that the right spelling? Yep. You can see here we don't have the attribute that we need. So junk item, just to grab, make sure we get that. It's blueprintable. And copy that to our consumable base. We're going to throw that in there. We're going to save. Hop back into the editor. Cancel out of this. We're going to do a live code compile. I'm going to pause the video again while this code compilation runs through. It should be really quick, but you never know. So I'll be back in a moment. Alright, so that live code compile finished without issue. So we're just going to close out of that window. We're in our consumable folder. Going to go blueprint down here in all classes, consume, consumable item base. We're going to select, and this one, BP mushroom, because there's going to be multiple, I'm going to say mushroom 01. Now, depending, you may want to provide alternate names, things like that. That might be a little more concise, like Portobello. It's the only mushroom name I can think of. I know there's lots, hundreds and hundreds and hundreds of them out there. Thousands even. But I don't want to go to that level within my blueprints. So I understand the mushroom that we have currently in the project. Mountain environment, I think. Nope. Conifer... The cave kit. Okay, I couldn't even remember where I put it. And this is where, if anyone's watched my intermission episode, asset paralysis. This is the sort of thing, you've got all this you're trying to hunt for. I've got like 139 static mesh, and like 100 of them are doors or door related. But anyways, so we're going to just select that. We're going to bring this back, add that to our world mesh. We want our item weight to be 1. Resource tags, we don't, this is something I may change in the future, but you could here, I plan on not having any resource harvestable from a mushroom, but you could have something like organic matter, depending on how detailed you want your game to be. Max stack size, I'm going to say, is 25. Again, we don't have an icon. Icons, I don't plan on covering too much simply because there's 1,000 different ways you can do it in different styles for your project. There's icon creator plugins you can get. There's multiple different ways. So I'm just going to leave icons out. You will notice as we start getting further into the series, I have icons because I've created them myself. I may cover briefly my process. I'll see if there's any interest. But if that is something that is interesting to you, you want to see the process of how I create the icon, then leave a comment and I'll see about that. For now, unknown mushroom. A strange mushroom. The reason for that is I honestly have no idea what that would look like or what sort of mushroom that looks like. So compile and save that. Now you'll notice up here it's separated. We have item base and we have consumable items. So stat adjustment, we're going to go health. I want to actually say -5. It's a poisonous mushroom. Well, we do it. So here we've got all 4. We can't do a 5th because there is only 4. Stamina is going to be, I'm going to say +10. This particular mushroom I'm planning on ripping out more than likely, or readjusting these. Hunger, we're going to go 5. Thirst, we're going to go -5. Yeah, -5. So what this would mean is this particular mushroom, if a character ate it, it's going to damage their health. It's going to lower their thirst further, but it's going to fill up a bit of hunger and give them a bit of stamina. So I don't want to use the term magic, simply because that implies something entirely different when you're talking about mushrooms, but it's one of those sort of weird mushrooms. Anyways, folks, so we have hit our 30-minute mark on this episode. I'm going to wrap things up here. Next episode, I'm actually going to cover moving things into their own, like moving the data types. Let me just bring this up so I can show you an example. That's going to be things like in the stat line component. We're going to move these into their own independent header files. And the reason being for that is we want to make them easily accessible to any class that needs to use them. You're going to notice that happens a lot. Like, go to definition here. It's going to open it up. Yeah. You have the Unreal string, which most of this is unneeded. A lot of it is just, actually, no, this is a very bad example. I shouldn't have used string, so ignore that. Either way, though, so next episode is going to be moving things into their independent header files, and after that we will continue with the item and inventory system. It's just those data files really are needed to move forward easily. So thanks again for watching, everyone. As I mentioned, if you do have an interest in seeing how I create icons, please let me know in the comments. I will, if there's enough interest, I will record an episode on that. But as in always, any comments, questions, concerns, suggestions, please feel free to leave them in the comments below. Thank you for watching, and I will catch you in the next episode. Hey there, folks. So last episode, I went through and created our custom data types. This episode, and then the episode before that, we were, and just quickly, our custom data types here. Shouldn't say created them. We moved them into unique files so that we can access them a little easier and not have to clutter up our different classes when they're compiled. However, before that, in episode 22, we actually worked on the consumable item base. Let me just bring up my diagram here. That would be this one here. My oh so lovely green check mark on that one is abysmal. We also covered that we don't actually need a dedicated consumable class. I know in the data type episode I said we would start working on the UI element of things. I actually got ahead of myself. We still need to work on the inventory component, and we're actually going to start on that today. So we are going to get rid of this. We're going to go back to the editor and bring over the content browser. And in here you can see we're in our C++ project files, public, and then we want components. And in here we have a stat line component. We're going to go right click, new C++, C++ class, tongue twister. Scroll down a little bit to actor component, select that. You can see all the file paths and everything are correct. And we're just going to rename it from my actor component to inventory component. We're going to create class. Now, because I am playing in editor, we do need to stop debugging. And just quickly hop back in. We're going to wait for it to prompt to reload, and then we'll stop. And this is taking a little moment here. Well, in the meantime, just while that's going through, there is a few things to cover. With our inventory, there is, as you can see right here, there is a tick component. Now, for most cases, I would say you do not want something like an inventory component to tick. However, I do plan on expanding my item system. I'm actually going to close out a bunch of these tabs because we don't need them. I do want to expand my item system. Actually, I'll bring this up here just quickly. And it's going to be around, let's bring up, what color do I want to use? We'll just use blue. It's going to be around this section here specifically, but I want to add in a, I'm trying to think the spoilage time. Like how long an item's good for before it goes bad. Like you could have, say, raw meat sitting in your inventory for a little while and then it goes bad. Because again, I'm trying to work on a slightly more detailed survival simulation. So, okay, there's our reload. So I'm just going to cancel the live code. It's off to one side here. Close out of that, hop into the editor, move that out of the way quickly, and close out of the editor. But anyways, as I was saying, I'm looking at expanding this through into a more detailed survival-orientated, or survival-orient, I can't think of the terminology I want to use here. A survival game that's got some fairly in-depth mechanics with things like food preservation, things rotting and stuff like that. So it's taken a while to close down. We're using, so it was about 3 gigs there when it stopped. Alright, so we'll hit reload because everything else there is done and it stopped debugging. So we have our inventory component here, and this is an actor component that we'll be putting on things like our characters, on storage chests, so on and so forth. And just like before, I'm going to fix a lot of this because it drives me nuts. There's multiple public declarations in these things. So anyways, so one of the very first things, and it's going to be a key portion when it comes to the game you're working on, is how you want to manage your inventory. So you've got, let me just bring up some oh so wonderful art skills. So you have the various different inventory systems where you have, say, your grid based, where you've got like I think the best example I can think of is Diablo, where you've got no, that's not what I wanted to do. I want selection, CV, where you got your inventory grid. That has its place. That is not what I plan on creating. But you say, yeah, you've got your, I'm just going to do that. And then you have your objects, which are like paintbrush. Like your objects fill up, say, a weird Tetris shape like that. Then you have like your list inventories, which are things like Skyrim. And then you have some hybrid stuff where you've got individual containers that have a list inventory, and the one I'm thinking of specifically with that is Project Zomboid. You have your different inventory containers that each have a max capacity, and that would be things like a bum bag, a backpack, a garbage bag in your hand, things like that. Close out of this, I don't need that. So for myself, I plan on having trying to think how to, ultimately I think I just want to go for the list inventory. I'm not too concerned about overall inventory management. So however, I do have some ideas in there that are sort of going to combine certain aspects. But anyway, so going down to the basics. So the first thing you're going to want, I've got cap locks on apparently. New property, edit default only, blueprint read write. Sorry, read only. Meta equals allow private access equals true. And I'm just going to copy that because we're probably going to use this a bit. So you're going to want a float value. And the reason I'm specifying a float, not an int, and I'm just going to bring this up, is in our item base, our weight is a float. And to save casting issues of, like, you've got a 1.25, and we're casting it into an inventory that's, say, using an int, where that 0.25 could be lost, you want to keep the same accuracy in your numeric value. So max container weight, actually no, we'll say max weight because it's not always going to be a container. So we're going to say max weight, and we're just going to start off with 100. Don't need the .f. Now we don't want an edit default only for this one. It's going to be visible anywhere. We're going to have a float current weight equals 0. And this is quite literally, this is how much it can hold and how much it is holding. And then now we need a way to identify the contents. Using edit default only allows you to like preload certain containers with inventory if you want, as a blueprint. So you could have like a preloaded, excuse me, my chair is squeaking, a preloaded crate with medical supplies, things like that. So now this is where it gets a little complicated. So you could have don't need the arrow there yet. T-array class U item base contents. However, it's not going to work because this needs to be T sub class of class U item base, and this is going to be that array of your items. However, that comes down to, we have max stack size, and I actually need to make a correction to what I said in one of my previous videos, because in the previous video I said we're not worried about the max stack size and the current stack size in our item base. I was wrong. We do actually want to include that here. I did some further planning between episodes and I realized we do need a current stack size as well. So I'm just going to copy that entire set there and change this to current stack size. And doing that, we do need to also add in int get current stack. It's going to be a const. We're going to return current stack size. And we're going to need to add some extra functions in here. So we're going to go U function, blueprint callable, bool add to stack, const int reference amount. Actually, no, we want to do this as an int. And then we want to do pretty much the same thing, actually, and I'll explain why we're using an int in a moment. Except from, instead of add to stack, we want to remove from stack. So we're going to create these definitions. I always do that go to instead of quick action create. So if current stack size equal to max stack size, we want to return amount. So what this is, what we're doing here is basically we're saying, okay, we want to add, say, 5 items to the stack. There's only space for 3. That's what this int is for. It's how many are remaining after we've added. But in this case, so if our current stack size already is the same as our max stack size, we can't add to it. So we're going to return else. No, we don't need an else there. We're going to have to use a local storage variable. Int used equals 0. So no, we don't want to use that. We want that remains. So we want remains equals max stack size. So I'm going to use some numbers here in a second just to explain that. And I'll do that in the comment above. Now, how did I want to do this again? So it was, oh, right, math. What is just an int math? Int. Floor. That was it. Remains equals floor. No, it's a clamp. My brain is not wanting to work today. It's been insanely hot and my brain is shut off. Okay, so UE5 C int clamp. Put one too many pluses there. Clamp integer. Why am I not working this one out? That's blue. Oh. Is it really fmath clamp? Oh, it is. I'm using fmath, reading fmath as float math, not Unreal Math. Okay. Fmath clamp, and that returns. So we want amount minus max stack minus current stack, and the max will be amount. And amount equal, oh no, remains equals. So just for the purpose of the maths here, we're going to say, let me add a comment so I can do this without causing errors. Amount is 10. Max stack size is 5. Current stack size is 2. So what this is going to be is, that tells us we have 3 left. Well, we have space for 3. So we're going to deduct that from the amount to get the remaining. And that's going to give us a value between 0 and current. So if for whatever reason this fails, it shouldn't, we can still get a result of 0. And then we want to current stack size plus equals amount minus remains, return remains. Now this is very janky and I'm going to think of a better way to do this. However, this is a very basic setup just to increase the stack size. And then we want a similar functionality for removing from the stack size. We want to be able to say, I want to take off 1. So if current stack size is less than the amount, we want to int removed equals current stack size. And then we want current stack size minus equals amount. Oh, sorry, no, this one would be equals 0. Return removed. So again, we'll use that same math. If this is 10 and our current stack size is 2, we're only able to remove 2. So that's going to say removed is 2. We set our stack size to 0, and then we're returning the 2 we removed. No, sorry, we want to return the remaining. So that's amount minus removed. Else we want to, like, so that's, just to be clear, this is we're returning how many we still need to remove. Or do we want to? Now this is one of those, it's going to be down to how you personally want to work the logic. I'm actually rethinking that. I want to say how many we actually consumed, so I want to return removed. So if we've only been able to remove 2 out of the stack, then we want to say we only removed 2. And otherwise it's current stack size minus equals amount, return 0. So now there is one other thing we're going to want to do here. I will cover that in a moment, but so the reason for this and adding these 2 functions in, and just because they are a little more complex, I added them to the source instead of in the header. But the reason for that is how we're going to be storing them. It's literally just going to be a T array where we just stick things in. And there's a reason for that. Is part of my inventory system, it's going to include drag and drop. If the player just puts it in their bag, it's going to go to the top, or for those who understand T arrays a little better, it's going to be at index 0. I know it's a little inefficient at code level, but and the reason being is, so the first item they put in their backpack, if they just keep throwing things on top and not organizing it, that very first item they put in is always going to be at the very bottom of the list. So it's sort of to indicate what items are closer to the top of the backpack versus what are towards the bottom. So, and on that note, we do need to add some functions to that. So, U function, blueprint, callable, bool, add item to stack. No, add item to top. And then we need class U item base const U item base. Yeah, reference item. And then we need another one, U function. I just copied that. Why am I doing that? Bool add item at index const class U item base item int constant reference index. I'm going to use IDX. And then one final one, bool add item to stack at index. Now these are probably not going to make any sense right now. I will explain them as we go. I'm going to be working on these slowly for the next couple of episodes, I think. Int reference IDX. So, first one, it's going to be very very simple. Add item to top. So if current weight less than or equal to, current weight plus item dot. Oh, I need to include item base. It's an undefined class. Or unknown class otherwise. If current plus item dot weight get stack weight. Yep, that's the one we want. Get. And we need to add that other function in there actually, because we got get stack weight, get current stack. We don't need that actually. Return item weight times current stack. That's what we called it. Yeah, current stack size. Item dot get stack get stack weight. If current weight was greater than max or weeks max weight. Return false, and down here it's return true, and the true and false literally just indicates did we successfully add it or not. And then what do we call this? Contents. Let's call it inventory contents actually. Inventory contents. I think it's because we're using const references. Get rid of those. So functions declared. No instance or load. that's what it should be, though. Oh, no, it's because I have this... my own brain is not functioning. T subclass of... Apparently I'm hitting keys I shouldn't be. Class. I've done this before and I'm trying to remember how we do it. Oh, capital I, that's why it's not working. Item dot. Sorry for sitting here in silence. I'm just trying to... Oh, there we go. That's just because I hadn't closed it off. Dot insert item at 0. There we go. So what we're doing with this one, and again, I apologize for that silence there. My brain was firing, but my mouth wasn't. So just going through, because we're just doing a subclass of, we need to use the get default object. And what that's going to do is it's going to do some casting for you to get the item or the original class. And then we can call get stack weight on that. From there, we can say, okay, oh, I missed. So that's greater than max weight. I removed that one. I shouldn't. So our check here is if the current weight plus this item we're trying to add's weight is more than our carry capacity, we're going to return false. And if it's not, we're going to add it to our contents. And then what we need to do is current weight plus equals that. And actually, because we're going to do casting, item weight, I'm going to do this once here because I don't want to do this twice. So just again to run through these. So we have, we're quickly grabbing the stack weight of the item we're trying to add. We're doing comparison. If that would put us overweight, we're going to return false. Now, some inventories let you go over capacity and you slow down. I'm thinking about that. That's a design decision I haven't been able to nail down yet. And this goes back to what I mentioned in the intermission. Not everything is going to be 100% nailed down as soon as you get past the proof of concept phase. The inventory system itself, I'm still up in the air about. That's sort of why it took me until episode 20 to get started on it. But anyways, from that, in my case, currently, I am not allowing you to go overweight. I may do that, but there'd be a lot of cross-referencing classes that I'm not sure I want to do yet. And by that, I mean your inventory is going to have to talk to your stat line and back and forth. So But anyway, so with that, as long as we have the weight capacity, we're sticking in our inventory and we're updating our current weight. Just so we can get this to build, I'm going to quickly define these. And we're going to run a quick build on this, just to make sure we have no build errors. And as long as this works, which it didn't, 26 protect. Oh, I'm missing a semicolon. Let's try that again. That failed. Found on 37. Oh, that's because let's fix these. Okay, we'll try that one more time. Line 37. Oh, I deleted the name. Wow. So this is another bit of advice I will give to everyone. If you're mentally not, I want to say sound, like this episode really proves, and I know most people would probably just ditch the episode, but if you're having an off day, don't be afraid to. Now, I'm not saying this in case you're actually working for a company. It's not the same. If you're working on a personal project like this, don't be afraid to just say to yourself, I'm in no state to be working on this right now. Wow, what is... Because clearly I'm really not in the state to be working on this. My brain is fried from the heat. It's a little late in the day for me, so... But anyways, so... Point of that being, if your brain's not in it, don't force yourself to work on it. You are going to make an untold number of stupid mistakes. And you're going to end up... just like, I'm probably going to end up coming back and looking at all of this work and going, why did I do this? But... Anyways... Oh, the build's finished. There we go. It has completed. Now, we're not at a point where we're ready to throw this onto a character yet or get any further than that. We still have a couple other items to expand upon. However, we have hit that 35-minute mark. Actually, no, this episode I'm going to let go over. I want to finish these off. Monkeys to that 30-minute recommendation that YouTube tells me to use. Anyway, so let's finish up at least these two functions. So, add item at index. Well, we already have right here, we have our logic. Now, I've just done something that, on purpose, that I hope nobody does. The second you copy and paste a chunk of code like this, create a helper function. In this case, I'm just going to do it here as a private function, bool over carry weight. No. Is over carry weight. And pass that in. Call it item. So we have this here. Well, actually, this is where I'm going to question myself on that, because we need to, like, it's this portion of code that we're reusing. Yeah, we're still copying and pasting. So we can change that to a float, actually. It doesn't need to be the item reference. So actually makes this a little cleaner. So we can just do a const float reference item weight. save that. So return true. And actually I'm going to make this a const and make it accessible to U function blueprint. Callable. So what we're going to be doing here is if and the reason being for this is it just saves, I can't even spell weight properly. Let's go back to our header. The reason for this is, as I mentioned, like if you want to have that potential to go over your carry capacity and it'll slow you down, doing this allows you to have some logic in there. It's like, okay, you can go up to twice your carry capacity before it denies. Okay, it's not doing that. So doing it this way, what that's going to allow us to do is when I change my mind, if I change my mind, it's going to allow me to only have to adjust this logic here instead of all of the logic in every single function. So let's do that. So add item at index. So that's if you want to put it in like the 4th slot. So it's pretty much the exact same thing, except we're going to add IDX to reference the index we're saying we want to add it to. However, and actually we don't want to make this a const because we want to be able to adjust this. Where are you? Add item to index. Just in case we have a math error somewhere. So if IDX is greater than or equal to inventory contents.num. So now to explain this, inventory contents.num uses a human counting system. It starts at 1 and goes up. Well, actually, sorry, it starts at 0 and goes up. If there's nothing in there. So if the index is, no, we want it to be greater than. No, I'm trying to think. If there's nothing in there, it's going to go to index 0. Okay, let me just bring up something here to help. And this is something else, again, don't be afraid to do. Bring up whatever you want, be it a piece of paper. I normally have a notepad I do this on, but again, it doesn't work when I'm trying to record a video. So you're going to have index 0, 1, 2. I can't write with a mouse. 2, 3, 4, and so on. So index 0, if that's, we're coming in saying we want to assign it to index 1. I'm just trying to think. So if we don't have any items, if it's greater than, if we have one item, the num is going to be 1. And index 1. Yeah. Okay. Sorry, I just needed to do the mental thing there. So what we want here, if the index is greater than the number of items, so we have one item, but it comes in, we want to put it at index 2. Well, that's not going to work. Let me bring this back. So index 0 is going to be our first item. Index 1 would be where we're wanting to put it. Index 2 doesn't exist. It's null. That's outside the array. So, yeah. IDX equals inventory.num. And does that create? No, actually. Insert a given element with the array at a given location. Index tells where it ends. This might actually throw an error. Well, either way. So now this one here, no, say either way. I will, obviously when we get to debugging, I'll be stepping through that. For some reason, I'm thinking if we're at the end of the index, we need to expand. But we'll cover that when we hit to that episode. We'll get to that episode. I'm not 100% on the Unreal Engine's T arrays. So add item to stack at index. This one's a little different because we're not just throwing it into the array, we're trying to update an existing. So we want you, actually don't need these classes in here because we have the header included. So we have uItem base pointer target item equals cast u item base inventory contents at idx int remain equals target item dot add to stack item dot get default object stack get current stack. If remain greater than 0, well, actually, we need to add this in here first. So remain greater than 0. Actually, I'm going to fix this in a second. I just thought something else. Actually, did we add a set stack size to this? Add stack. Nope, we need to add a set stack as well. Void set stack size const int amount. This one there's there's no logic, so it's just current, and we'll put it in the header. Current stack size equals amount. All right, so item dot get default object set stack size remain inventory contents dot push. There's a pop. That's removed from the front. Yeah. So push. No, let's add with these. Add item. Now, one thing we can do here is with this, we have already added this amount of weight. So we can just simply, at the very end before we return, add that in, return true. So just to explain, because my brain, you may have heard me mention it before, rubber duck debugging. Sometimes explaining things will fix what you're wanting to do or help you understand it and identify a problem. So in here, just like with the past two examples, we're grabbing the stack weight of the items we're trying to add. We're checking if it is over our carry capacity. If it is, we're just saying we can't add it. This is where you would potentially add in partial stack logic. I will be adding that in at some point in the future. However, right now, the focus, as it should be with all these projects, because we're still in not the proof of concept, but the pre-alpha, very early stages of actual development. We're just trying to get the basics in and working. So if we're not overweight and we can add it, we're going to get a pointer to the index. Now we need to add some validation like up here. So if the index is greater than or equal to, in this case, I'll bring back my little paint diagram here. So we have two items in the, oh well, doesn't let you change size there. I'm too used to things like Krita. Anyway, so you have two, come on, select. You have two items in your array. You've got them at item 1 and item 2. And you're coming in, so that's index 0 and 1, and you say I want to add it to index 2. Well, there's nothing in index 2 to add to. So what's going to happen with, let me just find that here. I pulled something up there apparently. Oh, I haven't finished my if statement, that's why. So index 0 and index 1 are going to be our two items. If we come into index 2, this is going to fail because that's going to be a 2. Well, there's nothing in there. So we want it to, but this is going to return 2 because there's two items in there. So we're just going to put a catch-all return false. And I'm going to do add error logging. So this is a catch-all in case we're index out of range. Yeah, you may have seen that in a lot of games. I see it coming up quite a bit because they don't always catch themselves. I don't want to say they don't understand that some of these things start at 0 or other things start at 1. Index of operators are always a pain, the short of it. But anyway, so this is going to get us a reference to the current inventory item. We're going to get the remaining, how many we can add to that stack. If we can add the full item, remain is going to be 0. Otherwise, we have something left. So we need to put a second stack in there. And no, we don't want to add because that's going to put it to the bottom. We want to put this on the top. So it's going to be insert item 0. And then we're going to adjust our weight, and we're going to say we added it. I'm just thinking if the index is greater than, yeah, no, that is what we want there. I was thinking we wanted to change something here. But no, that's correct. And that's correct there. So we're going to do one final build. Hopefully I didn't break anything here. And as long as all of this builds, I will be ending the episode. And hopefully that is it. But for now, though, because this looks like it's going to take a moment because it's going to have to rebuild all of the, item files as well. I'm going to pause things here quickly, and I will be back as soon as this build's finished. And I say that, and the build immediately finished. So it's one of those things, I swear. But as you can see, this build did go through successfully. Now, I do personally have some concerns, potentially broken. And what I mean by potentially broken there is this might not actually work. My concern is it doesn't dynamically expand the array. Actually, let's just check on that. UE5, I'll bring this over in a second. T-array insert. All right, let's bring this over so we can actually read this. T-array. place. Two arrays must come contain used in the engine. It's like a list or a vector, very similar to, I won't say identical, but very similar to a list or a vector. Add in place, puts them at the end of the array. Yep. Add unique ensures there's only one. We don't want that. Append adds multiple elements at once. Insert, like add in place, and append adds a single element or a copy of an array element at a given index. That doesn't. So where my concern is this particular function, insert, does not expand the array. Well, let's do a quick check and see. Didn't want to turn this into a C++. Get data plus index, element type index. Construct a copy in place at index. This new operator will insert an index. Okay, so no, it does. Exactly what I was concerned it wasn't doing. So with that then, folks, I'm actually going to close out of this. Don't want to leave it open. With that though, folks, I am going to end the episode here. I know this episode didn't really get much done, or appear to get much done, in the way of the inventory system. However, it does cover a lot of the core functionality that we need to use. And after that, next episode, we are going to be able to start expanding things a bit. We'll tie it into our harvest actor pickup and our logs that we've got, and we should be able to start at least pushing things into the player inventory. If not in the next episode, it will definitely be the one after that. So, as always though, thank you for watching. Any comments, questions, concerns, suggestions, please feel free to throw them in the comments below. Thanks again, and I will see you in the next episode. Hey there, folks. So last episode we did some work on our Visual Studio. Anyway, so last episode we did some work on our inventory system, and we started the process of actually being able to add items to the inventory, so on and so forth. Between episodes, what I did, I'll just pull over my content browser here. I created a couple of icons and brought them into the project. And I did also add a log item type and added the icon into the mushroom item type. Now, before we can start implementing these, we do need to add our inventory component to our character. So I didn't actually launch this in Visual Studio, so I can close out of the editor. So first thing we're going to want to do, obviously, is grab our inventory component include, and then we're going to want to go to our character base class. So in this case, it's TF character. Actually, and we also going to want to grab the header for that. In the header, we want to add the include for the inventory component. And then back in the header file where we have our stat line, we're going to copy the U property, put that underneath, and we're going to go class U, actually it was this U inventory component. Yeah, just for ease, we're going to just copy that. Save any typos. Class, get rid of the U inventory component pointer, and then we're going to go inventory. And at the very bottom, where we have the blueprint callable get stat line, we're going to add the same thing for our inventory. So U inventory component pointer get inventory const and return inventory. So the whole purpose for that is this just gives us a way that we can uniquely pull off the particular character's inventory component, and from that we can make the calls to things like add item, remove item, and so forth. So now we've done that, we want to go into our character source file, and we just need to add that to our constructor. So inventory, if I could spell, equals create a default sub object. Hate how that happens sometimes. Default sub object, u inventory component, text, and we're just going to call this inventory. So that is the very basics of what we need to do to the character. We're just going to do a quick build to make sure that we haven't added any bad code in there. And apparently it needs to do a full rebuild because we have 12 things building. So I'm going to pause the video, and as soon as this build's done, I will be back. Alright, so the build's completed. Don't actually know what was happening, but it locked up, so I actually had to restart my whole machine. But as you can see, the build executed. It took a lot of time. That's what, nearly 10 minutes. Either way, so we know all of this is working and everything we've added there. There is a couple more things we need to do. However, let's just make sure. Yeah. Okay, we've got that. So what we need to do now is, first of all, in our pickup actor and our harvest actor, just open the header files for those quickly just so we can take a look at the functionality we've added already. I'm going to close out of everything. So we've got our permanent mesh, our inventory item. So this is the item that we're going to put in the inventory. And see, right now we have this set as just a placeholder A actor. So what we need that to be is item base. And that we can just go up here again. We're just copying this for the purpose of consistency and making sure there's no typos or anything like that, because we're using a class friend reference there. So we're going to save that. And we're going to want to do the same thing in our harvest actor. Again, you can see we've got a class A actor. All right, so we've done that. Now we need to edit the source file. Sorry, my brain went blank there for a second. So we're going to start with our harvest actor and our pickup actor. We're going to start with our harvest actor because that's the mushroom that we've got, and we can just work from that and start on that one, make sure everything works, and then we can sort of copy the same logic over to our pickup actor. So as you can see, we've got some things commented out here. First of all, we need to get the inventory component. And what did we call that? So, well, I'm just going to start at the top here. I'm not going to remove it. So we want to include a reference to our inventory component header. No, I don't want the source header. I want the source file. So I'm going to grab that. And we're going to throw that up here in our include section. And we're just going to save to keep that as reference, make sure that's saved. So u inventory component pointer inventory equals caller get. Now we have an issue here. It's an incomplete class, so we need that same include. Don't need the door for the base character. So we want caller get inventory. So that's just going to return a pointer to, for now, the only thing we've got is the player character that's doing this. Further in the series, we'll have NPCs and stuff, because I do want to try and do some AI logic where NPCs can pick things up and such. But anyway, so we've got that. Now we have our add logic. So I'm going to see inventory add item to top, and that is just representing throwing this into the bag. And what do we call this item? Harvest actor base. This is the inventory item. Okay. Now we do have one issue. The way this is set up, we have an item count, and we don't have anything set on the inventory item. So what we need to do here, we're actually going to, where do we want to do that? If inventory item stack, static class, stack size, no, default, that was on default. Where is it? Get default object. No, okay, what is the, oh, we're not referencing the inventory item either, so we need the item base reference. So, inventory item stack U item base. Oh, yeah, no, that's the default. Yeah, I'm still default. Get default object stack. Get current stack does not equal item count. No, we don't need the else. So what we're going to do here, this is just some, actually we should probably put this in the, oh, where is it? Do we have a, no, we're just going to leave that in here for now. There is some cleanup. Like, we were going to want to do this chunk of logic in sort of like the spawning process. So what we're saying is if the current stack doesn't equal the item count, actually, what did we default that to? Current stack equals 1. And what did we call the add to stack? Well, actually, no. We are just going to go for a basic. We're going to add multiple items to the inventory based on that. So we're going to use the logic here. Equals -1. So -1 is a control number. That is a good -1, -100, -1,000, a number that you know is not going to be an expected or acceptable response is always a good control number to use. So we know we're expecting our remaining to be anywhere from 0 to item count. So below 0, which isn't an expected number, is a control value. So if remain does not equal, oh no, sorry, if remain equals inventory add item to top, no, okay. What did we do for that? Bool, bool, bool. Okay, no, sorry, my brain wasn't working here. So int remain equals item count, while bool full equals false, while item count, remain is greater than 0 and not full. Okay, so just to run through, we have one more thing to add before we say this is good. So we have our remaining. If remain is greater than 0, we're going to keep trying to add things. And we're just adding one item each time. Again, this doesn't work perfectly with everything we've got. But like I said, we're not, I'm in the hybrid situation between proof of concept and sort of starting to implement everything here. So we're just putting in some very rough logic, and there's going to be a lot of things we're going to be refining, refactoring, and potentially even completely ripping out. But anyway, so what this is doing is, while we still have something in the remaining amount, and we have a Boolean value of full, which is currently false, so while we have more than one item, more than no items remaining, and we're not full, we're going to continue. Now, add item returns, we're going to go to this definition just to step through it. So if we can add it, it's going to return true. If we can't add it, it's going to return false. So what we want here is full equals the opposite of whatever is returned. So if we've added it successfully, that means we're not full yet, and this is going to return true, but we want to set full to false. Now that we've done that, we want to go if full, and the reason why we're checking full first is it's a very simple, actually no, we don't, if full and remain, oh no, do we need to do that? No, so the full is just for us to drop out, and actually we can simplify this even further quickly. I'm just going to copy that, put this in here. So we're getting rid of the need for that full Boolean because we don't actually need it other than to drop out of the while loop. So if remain greater than 0, actually no, we want remains equals to 0, then we've got update harvest state is harvested equals true, and we can return. Else item count equals remain. Return. So what we're doing here, and I'm just going to comment this out so it's not called, potentially called in any way, shape, or form, even though this return should stop it. But I would like to keep this original commented code just while we're debugging. So just to step through quickly. So we have our caller's inventory, which is going to be our player character. We have an item count, and that is how many particular items, or particular instances, I should say, of our inventory item we're wanting to add to the caller's inventory. And what we're going to do here is just a while loop. So while remain is greater than 0, meaning we still have something to add, and we successfully added the item to the inventory, decrement remain by 1. Then, if remain is equal to 0, it means we've harvested everything. we're going to update our harvest state. We're going to set is harvested to true. If it is not, then what we're going to say is our remaining item count is equal to our remaining value. And this should never be a 0 value, because that's what this this captures here. Why is that not blue? But I give up with IntelliSense. But anyways, and then we drop out. So let's do another quick build on this. Hopefully this doesn't take 10 minutes. Yeah, this one's going a lot faster. Okay, so that's worked. What I'm going to do here, I'm going to put a breakpoint on that interact. And then, what are we calling? Add item to top of inventory. So let's open that up. Add item to top. I'm going to throw that in there as well. So what this has done for us is this has set up a very rudimentary, and since we added this in the last episode, I'm thinking about how I might want to refactor all of this. Inventories I've found, and this is why I've been, as I mentioned in the last couple episodes, been very reluctant to start on it, because the inventory component has always been that one piece that has sort of fought me when trying to implement it, because there is so many different ways you can do your inventory system. There's so many ways you can implement just a particular style of inventory system. Yeah, as I mentioned in the previous episode when we set up these functions, my goal, or my intent, I should say, is I want a inventory system that simulates just throwing things into your backpack, or simulates like being a little more organized. So like if you have a can of beans that you throw into your backpack, and then you throw in a pair of socks, and then a shirt, and then another can of beans, and then a book, the way they're going to show up in your visual representation of the inventory, and I'm just trying to explain, taking advantage of this loading time here, but the way they'll visually show up in your inventory is that very first can of beans will be at the very last item in your list. The book would be the very first item, and everything in between is going to follow the reverse order of how you added them in. And that's the whole purpose for this one here, where we're putting this at the top, and then we've got this function here that lets you put it into a specific place, and then you've got this one here which lets you add it to a existing item. Now I just caught something in here, and this going through in red. Oh, those are expected because they're pointers we haven't initialized. So that's expected. Let's bring this back up. 90% here. So scroll this back down. Now, if you're ever in a situation like this where you scrolled up to find a particular line item and you want it to continue going back to the live feed, you scroll all the way down to the bottom and click, and you just want your caret to be right underneath the last line, and you'll notice if I scroll this, oh, it won't let me because we're in this, it loaded the thing, but you'll notice now it's automatically scrolling down. If you want it to stop, just quickly put the caret someplace else, not at the very end of the log window. But anyways, so everything is set up here. I just want to check a couple of things. I'm going to pull over the content browser quick. First thing we're going to do is go into our third person character, blueprints, BP third person character, obviously. And we want to make sure there is an inventory component on here. And you can see, yes, there is. Oh, I'm going to change my engine scalability settings because it is set to a weird value from when I was taking those screenshots or creating those icons. But anyway, so back into here. So we do have our inventory component. So the right values are changing. You can see max weight, you can see current weight, and you can see contents are 0. And you can see you can add some default items. I'm going to delete that one though because we don't want it to be there. So we're going to compile and save. Now we're going to move content browser out of the way. We're going to hit play. This is probably going to take a couple seconds to log in because it's the first time since the engine started. Oh, nope, there we go. Oh, maybe I didn't have it set to medium. That looks really low quality compared to what it was previously. Anyways, we're going to run up to our mushroom, get our pickup text. We're going to hit F. Now we're in a breakpoint, so let's go hit F10. Remain equals 1. Inventory, you can see it is set to our player character. If we hit F11, it'll hop us in there. Access file. What? Why is that null? Okay, well, this is a good example of adding in some error handling to your code. So, if item is valid, can we do that on item? Yeah, we can. Well, hopefully. So we're going to add that in just as a precautionary. Maybe I didn't save my blueprint from when I updated it. I never updated the mushroom blueprint. That's what that was. However, this is a good example of how you can add in some error handling. And then, so to do add error logging for invalid item. So right there, that is something you can add in. It's a precautionary thing. It's like, okay, if the item isn't valid, just say it didn't work. So we're going to restart the editor. This should launch almost instantly because we had that one minor code change, and we've launched the editor already since we recompiled. And you can see it moves very fast. And I will check the mushroom blueprint just to make sure. So move this over so you guys can see what I'm doing. Blueprints, dev, because I realized I never actually added that to our harvest test. As you can see, inventory item is none. Now I'm just going to move this off the screen. Hey, thank you. Apparently it also minimized the game of the main editor window. Why are you being so slow and unresponsive? 7 gigs, but almost zero CPU usage. Like, what is going on? There we go. I'm going to move the content browser out of the way. I'm going to expand the editor again, and we're going to play quickly because I want to make sure that is valid we just added actually catches that. Because that's the last thing you want is something like that happening in your final game. It's going to cause things to crash. You don't want your game to crash. So let's walk over. Hit F to interact. So we're going to go down, hit F11, hop in. So you can see here item is a null pointer. We've returned false. Okay. Remain equals 0 still. Equals 1. We're good. That worked. So we'll just hit continue. Okay, we no longer have a bug. Things still carry on in the editor. So drop out of the play and editor session. We're going to bring back our blueprint. And just over in the content browser, actually I'm going to just bring this over. Consumables. We're going to select our mushroom 01. And then over here, just click that. And you see it adds it to it. Compile and save. I'm going to move this over one more time. We're going to play one more time. And actually what I'm going to do, because I'm expecting this to work. No, I don't want to. Thank you. Character. Select you. We're going to go down to our inventory. Oh, we have it as edit default only, so yeah, it's not going to show. Either way, let's pick up the mushroom. So item count remaining is 1. We're going to go in Item is now a particular item. It's no longer null. So item weight equals, it should be 2.5, I think we set for this. One. I'll have to check that because this might not be returning because it's get default object. If it's over the carry weight, why are we returning false there? Okay, so we're going to stop here a second. We're going to open up our default mushroom. Oh no, item weight is 1. So we're going to go, I'm going to change that to 2.5. Compile and save. It's copper bar that was 2.5. That's why. Okay, so is harvested, item can't. Okay, everything there is good. We can close out of that. I'm going to try this again. Just actually before that, I'm going to hop back into Visual Studio. Go to definition. Go to definition. I'm going to add a breakpoint there as well. Run over to our mushroom. Pick it up. So hit that. We're just going to hit continue. Item weight, we can see is 2.5 now. Do I have my logic wrong there? Because it didn't hop into it. Current weight is 0. Yes, I have this backwards. So if we're over, because you can see here, is over carry weight. This is one of those ones where the naming convention is actually very clear on what we're expecting, but the response is inverted. So we actually want to go return true and return false. So we'll try this again. We're just going to launch the editor. This shouldn't take too long. We only inverted a Boolean response. Yep. Pull that over. All right, we'll try this one more time. Wakey, wakey, editor. All right, there we go. Apparently I've exhausted my video memory. I've just got something running on a GPU that it shouldn't be, but because there's nothing in here that should be using that much video memory. Okay, pick up the mushroom. I'm going to hit continue there because you know that works. So now this should go through. There we go. We're adding it in. We're adding the item to index 0. Inventory contents is now 1 with a max of 4. That should keep expanding that for us though. You can see we have our mushroom in there in the first place. Current weight. Remains minus minus, remains now 0, so we've dropped out of the while loop. If remains equals 0, we're updating harvest state. We're setting harvested as true, and we're done. So we'll hit continue. Now the mushroom is gone. As before, all of our collision and everything is gone. There's no trigger for our interaction text. We're going to take a quick look at our character and see if the current weight updated. Our current weight updated just because of optimization for whatever reason. Where's our inventory component? This wasn't correctly showing when we got to this return point. A lot of things get optimized out through garbage collection and stuff like that. But hopping back into the editor, you can see current weight is 2.5. So now I want to make one more change just so we can actually see the inventory contents. So we're going to go into our inventory component header, and right now, so just as before, But right now you can see it's edit defaults only. To do change back to edit defaults only. And we're going to set this to edit anywhere? Or is it everywhere? Edit anywhere. Visible anywhere, edit anywhere, yeah. I'm pretty sure at one point one was visible everywhere and the other one was edit everywhere. Oh, like they had opposite ones, so they probably fixed that. Or my memory just sucks. So we've made that one change. We are now going to hop back in. We are going to do a live compile quickly, just because that is a minor change. See if this actually registers. 4 actors. TF character is one of them. Sorry, those aren't. Let's harvest actor. Yeah, we're good on that. Not sure why you're changing it, but oh well. Character. Oh, I don't know if that actually worked. So we'll just quickly see. Third person character. Scroll down to our inventory. Yes, it did. So, okay, we're going to run over, pick up our mushroom. I'm just going to continue through all of these. Continue. And now you can see, get my cursor back on the main screen. If we expand our inventory contents, you can see at index 0, we have a mushroom. Now, we have no visual aspect for this yet. We do still have some work to do before we can get a UI component put together. I will warn you in advance, the UI is not going to be pretty. At this stage of things, I never worry about making the UI look good. It's going to be a case of it functions. Again, that goes back to if you actually watched my intermission episode, the first one, I should say, because I do have more of those planned, that don't worry about... That's why it keeps resetting to that, because I'm not closing the editor properly. Anyways, don't worry about making your project look beautiful right at the start. Your project will probably look like somebody slapped makeup on a pig for quite some time before it starts looking good. And the reason being is you want to worry about the functionality of the game. You want to make sure your code is solid, your blueprints are solid, before you worry about making things look pretty. In all honesty, there's only one game, at least, that I have seen that has succeeded using the opposite approach of we want to make it look pretty and then make sure it works, and that was The Forest. For anyone who's played that, and one of the reasons for that is the guys behind The Forest, from my recollection, and I may be incorrect here, but my understanding is the guys who created The Forest are visual effects artists first and programmers second. And that's not to say The Forest is a bad game. I love it. I have hundreds of hours into it. So anyways, folks, so that is going to be the end of episode 25. We have got it, so we are now actually storing items in our inventory. Next episode, we're going to be making sure our inventory saves. That's probably going to take up all of next episode, so that's going to be what? This is episode 25? Yeah, this is episode 25. 26 is going to be making sure it saves, and 27 should be the UI visual aspect of things. So, as always though, folks, any comments, questions, concerns, or suggestions, please feel free to leave them in the comments below. I try to respond to everything that goes in there. Thank you for watching, and I will see you in the next episode. Hey there, folks. So last episode we went through and we set up our inventory component on our player character where we can pick up items and they do actually get stored in our inventory. So as you can see here, we just picked up the mushroom and we do have that one item in the inventory, and the current weight is 2.5. out of our, I believe the max I set to is 100. So this episode, what we're going to do is make sure that the inventory is actually saved across game saves, not game instances. For this, I had actually launched from Visual Studio, so we're just going to close the editor, and I'm going to bring up Visual Studio here. So the first thing we need to do is here in our inventory component, we need to add in the save interface. So we're going to do the same thing we did with our stat line component. You can just see we need to add a public iSaveActor interface. We also need to include that header reference. So I'm just going to grab that and throw that into the inventory component. Save everything there. And I grabbed an extra bracket I don't need, so I can get rid of that. Clean up these files. Now there's a couple of things we're going to want to add the save game tag to. We're going to want to add that to our inventory contents, obviously. So I'm going to go save game. Now, for the purpose of the save game, we're also going to want to add it to our current weight. And because I do plan in the future to offer ways to increase your carry capacity, like you pick up a bigger backpack, things like that, I want to add it to our max weight capacity. And the reason being for that is I want to make sure the current state is saved so that all that information is already there. Now you can add things in like a function of recalculate weight, which is something I may actually do depending. The other thing we're going to want to do, and this is just because it's what's I'm going to call a dynamic variable, is over in our item, because we ended up adding in this current stack size, we need to add save game there as well. And from that, I'm trying to think if there's anything else we need to add. Right now, I don't believe there's anything else we need to add. However, we're going to want to use some debugging within the game instance for our saving and loading. So we have our two player-related ones, get player data. I'm going to throw a breakpoint on there. And set player data was the other one. And I'm going to throw a breakpoint in there. Now I'm just going to build the project and launch the editor. This shouldn't take too long for those minimal changes. But kind of surprised we have so many things. All right, that built. So we're going to launch the editor. And again, because I was just in the editor through Visual Studio, this shouldn't take too long to load up. Yeah, it's going pretty quick here. All right, there we go. So I just having a drink quick. So we'll play an editor. We're going to walk forward, pick up our mushroom. I'm going to walk over to the just here by the door. I'm going to hit 7. That is my, oh, I still have a breakpoint there from my other debugging. I'm going to hit continue. So we have our gathered player data. You can see we're getting a reference to our player character, which we have. We are getting their interface, which is there. Oh, actually, I'm going to fix that to do. We now are, ignore changes. Yes, I know. So we're getting our save actor data. So let's just take a look, see what's there. We have no component data yet. We haven't added that in. We do have our actor transform, rotation, was spawned as false because it's the player character class. So we're now going to do our serialize. And we can see here in our byte data, it now has a bunch of information. Now we're going to do our components. And I'm just going to drop through to the save component data. It's not going to let me because that. So I'm just going to quickly step through these. And what is this actor component? That's the stat line. And this should be the inventory. So get the component data. We haven't implemented this function because right now there's no custom information we need to add in there. We may need to as part of the save work. it may just work as is. This is sort of something I never fully finished off in my last attempt. So, okay, we're going to serialize. I'm going to take a look at that component data. And to most people, this is going to mean pretty much nothing. And if you hit view, it doesn't actually show anything. I just want to take a quick look to see if I can identify anything. Content. Stuff is way down in there. There we go. Okay, so you can see it's a little hard, but you have BP mushroom 01. So it is referencing the inventory content. Not seeing any additional information from that though. So we may consumable, that's its class. Okay, so we may need to do some work there. I'm going to tweak things so it actually that mushroom has a different item count. But anyways, we're going to step through, continue, add that in. We're done. We'll be done here. That should be all of our savable components. Yep, so we've got that. We're just going to hit continue. Take a quick look at our character here. And just see, so we have our inventory, we have our mushroom at index 0. I'm going to move over to the stairs. I should just run. Jump up here. I'm going to put 9 to load. Then I'll put a breakpoint on that. But you can see we're back here. Anyways, I'm going to go back over here. And we'll just head into Visual Studio. Set. Why was that not called? Load game. Yeah, it's right there. Oh, because that change I made there. Okay, so what we're going to do, we have saved the game as it's shown. I'll just quickly show again. We're going to hit F9 to load. It moves us back by the door. The mushroom is gone. Our trees are still there. I'm going to drop out of this, and I'm actually going to close out of the editor. So this shows something I do recommend, and I didn't think about this myself. Try not to make edits when you're debugging. Save those edits for when you're not like stepping through, and we're not really debugging, but we're stepping through the code. But yeah, try not to make edits like I did here of putting a to do so I could find it in a task list. Yeah. So we're going to rebuild. This should be almost instant because we haven't changed code. We just updated a comment. But this is also Visual Studio, so who knows? Dev load game, that calls in load game. Step through this. There we go. It's done. All right, so we're back in. We're going to hit play. And then 9. Okay, so there we go. That is why, is because I'd made that change. So I'm going to go, just continue. Get a reference to our player character. We've got that. Interface is good. Player data, dot actor transform. Well, actually, let's just look at the player data. That stores everything we need. Component data. Current weight. Float property. Inventory component. Yeah. So, just step through. And then we found that. What is this actor component? It's a stat line. So I'm just going to do that. Hit continue. Okay, that is our inventory. Does this let us see any of the information here? max weight 100, current weight there. Okay, that looks good. So I'm just going to hit continue. We're going to go over to our character. I'm going to take another look. Check our inventory. As you can see, we're in front of the door and we have a mushroom. So, as of right now, that looks like we've actually got the save portion of the inventory complete. So that actually happened a little quicker than I expected. So give me a moment, I'm going to pause the video and we're actually going to start on the UI aspect as well. Alright, I'm back folks. Apologies for that. I wasn't actually expecting the save system to work as smoothly the first go around. I thought there'd be some more work involved. I do suspect there's probably a couple other things that still need to have some work done to them, but we will get to those when they come up. So, as mentioned, we're going to start working on our UI aspect of things. Now, the first thing I want to do when the content browser wants to respond, we'll bring this over. So we need to add another data class. So we're going to go to our C++, the project, public, and again, you'll notice it's not in here. We don't have data types. And the reason being is that's not something that is directly exposed to blueprints. Directly exposed to the editor because it is just a data type. So what we're going to do here in the public folder, right click, new C++ class, none. Going to select our data type folder. And you can see it puts both the header and the source file in the correct place. And this one we are going to be calling F inventory because it's going to be a struct inventory UI data. We're going to create that class. Now, because we are running out of Visual Studio, this is going to take a moment to respond and prompt us with that reload. We want to wait until we get that reload prompt before we close out of things, though. And just in the interest of time, I am actually going to pause the video again until all of this is done. Alright, so that did take a couple minutes for it to go through. Turns out I had my Windows Defender live scan still running. I really need to figure out how to turn that off permanently. Anyways, so I've closed out of the editor and we have our reload prompt here. So we're just going to hit reload. Now, because we're creating a struct, not a class, we can just remove these two items here from our source file. And we're going to go into our header and do the same thing. Now, we are going to be following pretty much the exact same process we did with our other data types. As you can see, we've got our component, so on and so forth. And pretty much all of that is just pure header file work. So we're going to open up and just take a look at one of our other ones. Let's take our... Oh, I already created it. That tells you how observant I am and how good my memory is. We actually already had the data type, so we don't need the FUI data. So inventory UI data. We have item UI data, which is exactly what we were looking for. So I'm just going to close out of those two files. Now, over in your Solution Explorer, right click on the individual file, remove. It is just going to remove the file from the solution. It doesn't actually remove the file directly. So we need to right click, open files, folder explorer. I'm going to pull that across. Now, I've mentioned this in other episodes, but it's been a while since we've had to do this. It opens in the intermediate project files. You want to go back to your project folder, source, project, And then you need to do it in both the public and the private files. So data type, inventory UI data, private data type, inventory UI data. So that's that one there. Again, my apologies. It tells you how much I've been paying attention. However, we do need to actually expand this. We're going to add another one here, and we're actually going to put it at the top. It's an int, and it's going to be item index. And I'm going to default that value to -1, because again, that is a control index that's not a valid range. That tells you there's something wrong. So we do need to also expand our default constructor. Const int reference index, not semicolon, and spell const properly. And then just finally we can do this item idx equals idx. So just quickly to explain what this is for. This is going to grab the information from our inventory content, and it's going to give us the index in the array for the particular item, the item name, the item description, and an icon. Now you can go through, and actually I'm going to add that here as well, but this one we're going to put down the bottom. I didn't go down far enough. Int item count. No, stack size equals 0. And again, 0 is a control number for default initializer, because we know if it's 0, it shouldn't be there. So, and we'll do the same thing here. Const int reference count, stack size equals count. So now that we have this, I'm actually going to open up the source file just so I can grab the include. We want to go back to our inventory component. Going to throw that include at the top. You want to do that before your generated .x, .h. This should always be the last include. And then down the bottom here, we want a U function that is blueprint callable in our public section, just to be clear. Yeah, okay. I was just trying to think how I wanted to do this, and I was taking some look at my previous attempt here. So we want T array. Open that up so I get the right name. It is F item UI data. Okay. T array of F item UI data. Get inventory UI data. And we want this to be a const. All right, and then we just want to create a definition for that. Now here, we're going to do a little bit of work. I'm going to pull that out, put this up the top. And as with all of our others, we're just going to create a T array for the FUI data, F item UI data, and we're going to return that array, but we need to populate it, or potentially populate it. So we're going to do for auto I, what do we call that? Inventory content? Yeah, inventory contents. Inventory, if I could spell. And what does that derive to? Auto does not deduce reference. A possible unintended copy is being made. Yeah. No, we want const auto because we're not changing that. Yeah, no. So then we're going to want to do F item UI data, item data, we just want to go I. Get default object. Oh, what did we call these? Let's get, I'm pretty sure we added in all these helper functions. We didn't add all of them in. We're missing a few. So we do need helper functions for the rest of these as well. Oh, no, we've got that get UI data. So this is something else you may come across. I'll actually stop here for a moment. You try to be proactive when you're writing your code, and you know you're going to need to do something. So you do something in this case of we created a struct to return this one, and I completely forgot about it. And you're going to have this happen periodically. So current stack size, no, that's index. So we need to modify this slightly because our initial thoughts on this one were we're just going to return that. So how did we adjust this? So it's index and then count. Oh, apparently I collapsed that with a key combination. So on the end here we want current stack size, but we need to include the index. So what we're going to do here is actually as an input parameter, const int reference idx, and we're just going to pass that into the generation. So we're generating the UI data. Now we need to adjust our inventory component. So in here we're fine. It's actually in our source file. We don't need to use a for loop like this. Actually, no, we could. So what we're going to do here is int I equals 0. Actually, I'm going to call that idx so it's clear. So ret.add I.get default object get UI data idx plus. So what this is doing, obviously we're creating the array. We are doing a constant iterator for our inventory content. I may want to change this to just a standard for I equals, because I'm not a fan of that auto does not deduce references. A possible unintended copy is being made. Actually, yeah, just for my own sanity, because I'm not happy with that. For int idx equals 0, idx less than inventory contents dot num idx plus. No, lowercase idx. And we can get rid of that reference there. And this is going to be, delete both of those, inventory contents idx dot. Okay, so as I mentioned, this may not, before in previous episodes, this may not be the best way of doing it. I am following what is normal C++ programming approaches. I won't say patterns or anything like that, but this is how I would do it if it was a normal C++ under the circumstances of I'm wanting to account for references and such. I know they're not references to that degree, but either way. So now what we've done ultimately is we've provided a way for the inventory to provide some information that we can use in the UI. So we're just going to build the project quickly, and as soon as this is done, we'll be hopping in and we'll be doing some UI work to our HUD. Just while this builds, I'm going to pause and I will be right back. All right, so that build went through and we are in the editor now. What we're going to be doing is taking a quick look at our UI and making just some very basic, again, this is not to actually create our final UI. This is just for some very basic debugging. And that's why right now this is all being done through the third party instead of in our actual project folder. So just open the dev basic HUD. And where did that open up? Oh, there we go. So first things first, we're actually going to go over to our graph. Components, action text values. So we don't have any way within the HUD to reference our inventory. So what we're going to do, create a variable, create a variable, and just call it our inventory. The R is to represent that it's a reference. And in here, you're going to inventory component object reference, moves it up here where our stat line is. So we're going to just compile that. Now we want to instance editable, expose and spawn, which is actually the exact same thing we did for our stat line. Compile and save that. I'm going to move this out of the way quickly because we do need to open up our third person blueprint quick. Okay, bring this over. Oh, come on. Respawn content browser. There we go. Okay, so in here you can see, where's our begin play? We now have create basic HUD. We need to compile. Oh. That has changed. Let's go find, that is the one. And, oh, refresh node, where is it? Refresh node, there we go. I thought the compile caused it, so. We can just pass that in here. Now we did add a function for get inventory. However, that is not needed here. That is going to be for things like our AI. I just wanted to clarify that. So now we've added that in. We're done in the third person blueprint. We're just going to compile and save. And for clarity, just in case anyone's wondering, next to your compile button, there's the ellipsis. I think that's the right word. In there, save and compile on success only, never or always. I have it on success only just in case there's something I've broken and it doesn't instantly save it. It can be frustrating, but I recommend using that over always. But anyway, so we can close out of third person blueprint, and we can close out of all of these little sub functions and just go to our event graph, right click, custom event, toggle inventory. And this is going to take an input of a bool, which is just going to be show inventory. Now that we've got that, we want to add some basic visual elements to it. So we're going to go to designer. We're going to add a stack box to our canvas panel. Name that inventory area, sorry. Change our anchors to the center. We want the position to be, well, actually, first of all, we want our size our box to something realistic. So we're going to go 800 by 600. And then just do half of that value as a negative. So negative 400 by negative 300. That'll put it pretty much dead center. Now, this isn't perfect. This is exactly, as I mentioned earlier, this is to get it working. Now, actually, I'm going to half these sizes. That's a little wide for what I want. So we want this to be minus 200 and 400 wide, because we're just going to create a stack. But what we want to also add is get a scroll. We want to add that in here. Scroll box, we are wanting to name this inventory scroll area. We want to make that a variable, and there's a reason for that. We want it to be a fill, and just compile and save. Now we do need to create our child widgets for each inventory item. So I'm just going to move this out of the way quickly. In our UI folder, in our third person, I'm just going to right click, user interface, widget blueprint, user widget, and this is just going to be dev widget inventory item. And we'll pull that back over. So again, we're going to go to our graph to start with. We're going to add a variable, and we're going to say item data, and that's going to be the item UI data. Instance editable and expose on spawn. Compile. Now we're just going to take a quick look to see what we have in there. So in this, we have, oh, it's right up here. We have our index, our name, our description, our icon, and our stack size. So what we're going to do, I'm just going to pull this over quickly, get that, and we're going to break, if I could spell that, break UI data. So we have a visual representation of that. So first of all, these three items here are the big ones to worry about: the name, the description, and the icon. So we're going to go over to our designer. We're going to start with a stack panel. We don't need to start with a canvas for this. Now we want our, or actually no, we do want to start with a canvas for this. Sorry. So right click, wrap with canvas panel. In the stack panel, we want to have the orientation to horizontal. Now we want to add another stack box inside there. We want this to be vertical. We also want to add an image. And this format is purely how I'm roughing these out. But anyway, so add that inside the original stack box, and you can see it's gone underneath. You want to actually put that in front, above. I've got these the wrong way around. We want the first one to be horizontal, and we want the second one to be vertical. On the image, name it icon, and it's obviously a variable. And then we want a text box, text block. Put that in the second one and drop a second one in there as well. The first one we drop in is item name. The second one is item count. Now on the item count, we want it to be right aligned. On the item name, we want it to be left aligned. On the parent stack box, we want it to be fill. On the icon, we want it to be fill. On the original stack box, we want to change our anchor to this one here. And we just want to set that to, well, roughly how big is this? Okay, I'm going to sit there, that line, so it's there, and we're 2 down, so it's there. Yeah, icon, auto. Well, we'll just leave it at that. So just quickly, for the item name, you want to set it as variable. Item count is variable. I'm just going to compile and save here. Now we're going to hop over on the graph. So on the construct and pre-construct, it's really down to actually no, this one you want it on construct, not pre-construct. So off the event construct, we're going to icon, set brush from texture. We're going to get the item icon from our structure, pass that in there. We do not want it to match size, and we're going to just pass that over. Then we're going to get our item count and our item name. Set text on the item name. We're going to pull off our item name pin, and we are going to just duplicate that. Set text, Why is duplicate not working there? Warning, open clipboard failed with error 5. Okay, I want this. Copy and paste that then. Going to item count, add that in there. Now stack size. You can just drag that over and it's going to create a text to integer. Minimum digits, maximum digits. So if you want to have it so it's always, like say if you have 1, it's 0, 1. You want the minimum digits to be 2. We want our maximum digits to be 2 as well in this case. Just collapse that again, drag that over. Now one thing we want to do is make sure our data is valid. So we're just going to go valid off that. No, is valid. If I could type, apparently I hit something that caused a breakpoint. I'm not sure what it was. Valid. Is valid. No. All right. So anyways, we're just going to compile and save that for now. And running a little over here, but I will try and get some basic setup done here before we end the episode. So back into our HUD now. We're going to go to our graph. On toggle inventory, we're going to put a branch off the show. And the reason being is if we are hiding the inventory, we don't need to do any of this logic. If we're showing it, then we do. So if we're showing it, we're going to grab our inventory, get UI, inventory UI data. So as you can see, because we made it a constant function, it doesn't have an execute pin. We're not worried about that. This only happens, so it'll only have an execute pin. We only need that if we are wanting to do some other behavior with it. But we're going to grab that, drag off the return, and we're going to do a for loop. Actually, the very first thing we want to do is inventory scroll area, grab a reference to that, clear children. What this is doing is anything that may have already been in there, we're going to get rid of just to make sure that it we're not like double stacking the information. We're going to just connect that to the true, and then we're going to go to the for loop. We're going to create widget, and this is where we want this to be the dev, and then get owner, get owning local player. That's the one I want. Get owning player, sorry. We're going to grab this because we do need to add a reference to the owning player. We're going to take this return information, we're going to put that in there and connect the for loop. And then what we're also going to be doing is the scroll area, we're going to add children, or add child specifically. We'll just add that in there, and we're done our for loop. Now, what we want to do is, did we not set that as a variable, the inventory? No, we didn't. So set your inventory area as variable, excuse me. Back in our graph, we're going to grab our inventory area, drag off set visibility. From the visible state, we want to drag off a pin from that and do a select. Our show inventory, we're going to just drag that over completely to the index. And for ease, we're going to drag our false condition to that, and then our completed for each loop to that. Because this functionality we can set for both. Now, if we're setting true, we want it to be visible. If it's false, we want it to be hidden. Compile that. We're going to save. And then we're going to hop back into our third-person blueprint quickly. We are going to add a similar thing to this. We have 7 and 9 for our save. What I'm going to do is we are going to have key down, I think. Oh, keyboard event. That's it. Keyboard event. Where is I? Keyboard event I. we are going to get our HUD reference and toggle. Now we do need a way to indicate the state, so we're just going to add a quick variable in here, b inventory shown. We're going to add a set. We're going to add a get. Off the get, type in not b for not Boolean. We're going to set the value. Go to that and go to our toggle inventory. Now, right this moment, it's still going to allow you to walk around and things like that. This functionality doesn't really work for what's the term I'm wanting to use here? Proper inventory logic, like showing and closing. This is just so we can see the inventory and we can dismiss it as well. Because setting your game mode to UI only and things like that, with that, the controls within the player character don't respond. You need to add the logic to the UI. So we're just going to compile and save, and we're going to see if this actually works. I'm going to drag the content browser out of the way. I'm going to hit play, run over to our mushroom, pick it up, and then, actually before we start, I don't want to have any problems. I'm going to open up the HUD quickly, go into our graph, and I'm just going to throw a breakpoint on the toggle inventory on the branch. So move that out of the way. In here, I'm going to hit I, and our breakpoint was hit. So you can see pass through false. So that's going to go through here. Okay, that shouldn't have been false. That should be false to start with, so it should have been true. We're going to hit I again. We'll come back over. Is that now true? It is now false. Okay, what have I done wrong there? Open up our third-person character. Oh, that's my problem. I never passed through that. Okay, so fix that. Go back into the game. Run over, pick up our mushroom, hit I. Okay, pull this over. Okay, you can see we're passing through true the first time, so we're clearing the children. Num is 0. Huh? No debug data, add to child. Set visibility. And we'll move. Move this out of the way. So obviously didn't fix the image properly, because you can see, but we have unknown mushroom, quantity 1, and we have a scroll bar. So the image isn't being set properly, and obviously we can't scroll, but you can see we have a scroll bar there on the side. So let's quickly see what the issue is with that. So go to our content browser, pull that up, pull that over. We'll go into our project file, folder, textures, icons. Okay, I do have the mushroom icon. Blueprints, items, consumables, BP mushroom. Pull this over. You can see I have an icon. So that tells me the image isn't being set properly, or the size isn't being set properly. So let's go back to our UI. We're going to open the inventory item, bring the content browser over, go to the icon, and where is the brush information? Here we go. Image size, I'm going to go 64, 64. Zoom in on this. And I will say straight up, UI is not my strong suit, so there's probably a lot of things here that, size to content, I know I missed that one. Justification, I changed the wrong justification values. So now we'll go into the graph quickly. So we are, okay, let's try this again. So That is working. I'm going to move the content browser out of the way. I'm going to push play. Actually, play, please. Thank you. And actually, before that, on our inventory item, on event construct, I'm going to throw a breakpoint as well. So in here, pick up the mushroom. I'm going to hit I. So in here, we can see, again, it's coming through as true, clear children. We're creating each of these. So here we go. No debug data. Okay, let's hope that works. Move this out of the way. So clearly I've got something going on in there that's not correct. It could be my UI settings, but from here you can see we at least have some fundamentals for the interface. We'll hit I again quickly and just bring that over. Excuse me. You can see we're setting it to false, which means we're going to drop through to the set visibility. Just continue, and we've lost the UI now. So we can toggle that. Actually, I'm going to get rid of that breakpoint because I don't want to keep hitting these. So you can toggle it off and on as we go. Oh, and got close enough to hit a tree. So let's do these. Yeah, so that is the very basics of the UI. And like I said, this is not intended to be the final form of the UI. It is just something so we can see we're passing information through. There's obviously a problem with the icon. I'm going to work on that to figure out what it is. I'm not quite sure what's going on. Unfortunately, the UI aspect of this episode wasn't planned, so a lot of it is me doing things off the cuff. But anyways, thank you for watching, folks. Next episode will probably be, well, no, wait, not probably. Next episode will be continuing on with the UI aspect, and then we're also going to get our tree harvestables as a pickup actor as well. We haven't done that yet. We have only provided harvest actors with the ability to add to the inventory. We need to have things like the world pickups, which are just items that are spawned in the world. We need them to be able to be added to the inventory as well. And then that'll actually help with some additional UI stuff. But anyway, so next episode will be either, I'm trying to decide, well, I'm not sure which one it'll be. Depends on how well I can figure out what's going on with the UI stuff. But next episode will either be the working on the UI, or it will be fixing or setting up the harvest actors, the log pickup from a tree to go into your inventory. As always, those folks, any comments, questions, concerns, suggestions, please feel free to add them into the comments. I do respond to those as best I can. Thank you for watching, and I will see you in the next episode. Hey there, folks. So between episodes, I did a little bit of poking around. First thing we're going to do this episode was we are going to fix our inventory widget. So I figured out what I needed to do for that. So I'm just going to open that up, and again it opens up in the other window. So the first thing we're going to want to do, I actually had my anchors incorrect on this stack box. We want our anchor to be the top left corner. We want to give this a fixed value of 200, and we're going to say 75. Is it too big? No, not 750, 75. And then the icon, we want to set this to fill and with a value of 0.4. That was retained from my playing around. I tried to reset everything I could. And then our information stack box, we want that to also be a fill with a value of 0.8. I understand they contradict each other because that's a 1.2 total, so it does shave off a bit, but that also gives a priority. So The other thing I did, which I didn't undo noticing here, is I just changed the font size down to 20 and 12, I think. 20 and 14, respectively, for the text blocks. So now that we've done that, we're just going to hit compile and save with that. And just for those wondering, or who may not know, that compile and save I mentioned in the previous episode carries over to everything that's any Blueprint widget. It keeps that same logic. So we can close out of that now. I'm going to move the content browser out of the way. We're going to hop into Play an Editor session quick. Yes, and it's being a little janky because it's the first time I've launched Play an Editor since I launched. Walk over, pick up the mushroom, and then we're going to hit I. And you can see we have, well, a very messy looking UI. So there is one more thing I want to do before we go through and fix up this inventory and actually sort of have the player, like you can see I'm not moving, well, I'm still moving with the camera and stuff, but I want to stop that from happening. First of all, though, we're going to finish up and get our log actors picked up, or being picked up. So this time around, I did not launch the editor from Visual Studio. I launched it from the Epic Launcher. So we're just going to close out of that. And now that's closed out, we are going to start working on our pickup actor. So we're going to go into our base class here, pickup actor base, and the respective source file. Okay, and you can see in there we do have some commented out code, and in there that is where we're going to be working. So as you can see, we have interact implementation. That's what we're expecting. Getting the inventory, well, all of this looks pretty much the exact same as our harvest actor. So let's close out of all of these other. No, I did not want to pin that. I wanted to close that. Close out of all our other files here. We're going to just open up our harvest actor. So there's the commented code we had before. What we're going to do, we're going to just grab all of the new code that we added. We're going to do the same thing. And the whole reason for doing this is because and for leaving this here, is this was my initial gray box thought of what I needed to do. And then we want to make sure what we actually implement matches this. So while we don't have an update harvest state, we can get rid of that. And you can see we have an incomplete class, and we don't know about that. So we do need to add those two headers. So we're going to grab those as well. So that is our character and our inventory component. Save those headers, and you should see that fixes almost all of it. We can get rid of B is harvested, because again, we're not doing that. What we want to do here is add in the destroy actor logic instead, because we're removing this item from the game world. So what we're going to be doing is this dot destroy. I think it's Q for destroy. Set auto destroy when finished. I believe this is the one we want. And the reason being is if we call destroy before, actually I'm going to leave this in. Put that in just so everyone can see, because I've ran into this issue before. Maybe they fixed this in 5.4. If we're calling this dot destroy, it's actually going to try to destroy it before this logic is finished. So, however, this should cover everything. We do want to add some of our failsafe in here, though. Inventory item. U item base, that is all right. So inventory item. Forgot to put my phone on silent. Okay, so did we not add that to our harvest actor? I thought we added that in. I'm actually going to add it here to our is interactable. Is that going to work? Yeah. So this is just a test. I haven't actually done this one before. So what we're just returning is the inventory item we're meant to pick up, is it a valid item? And if it is, then we'll say we can pick it up. If not, we'll just leave the world actor in there. Don't really like that, though, because that's going to... Yeah, no, I'm not going to do that thinking about it, because that's going to leave the potential for invalid actors not working. Like invalid inventory items causing the actor to not pick up. So what we're going to actually do here is if not is valid inventory item, we're going to just return. But we're also, as you've probably seen me in some of the other episodes, error logging. And I'm missing a closed brace. Bracket, sorry. All right, so now we've got that. Let's go and build. Now, as I was saying, going back to this destroy, to using destroy, I found in the past calling this destroy, like I've done here, actually triggers the destroy logic before everything is done, and it causes some access violation errors, which result in obviously crashes. So this is something, again, the reason why you playtest and you debug and you step through and do things as you're working on your project. As a developer, I don't recommend waiting until you've done like 1,000 lines of code or however much, or completed an entire piece to do your debugging and do through your step throughs. Because let's just say you wrote, what's my largest class right now? Probably inventory component, stat line component. Yeah. So let's say you wrote all of this stat line component code. And those are just some breakpoints I had left in there from my last round of testing. You wrote all of this inventory component code, and you had not once actually stepped through all of it. And then all of a sudden you find out you have an error in here somewhere. Your stat line's not working. Well, okay, this particular class, it's only 200 lines of code. And honestly, it's probably not even 200 lines of code when you look at all the white space and switch cases and things like that. But the point there is the more code you write before you test, the more unsure you are as to where in the code is the problem. So you've probably noticed over the last 20 some episodes that I'll do a bit, I'll test. I'll do a bit, I'll test. And that's, at least from my experience, the best way I've found to do it, because then you know, okay, this first portion I've done works. The second portion I've done works. Oh, this third portion, there's something wrong. So it's this code I've changed in the last half an hour, depending on how quickly you're working. But with that, this build is going to take a little while. It's the first time I've run the build since I did my last commit to source control. So I'm going to pause here, and I'll be back as soon as the editor is launched. Hey folks, so the build finished. However, sitting here I did notice, and thanks to IntelliSense, I actually have some bad code in two places here. First of all, in our adjust stat, which is actually something we're probably going to be implementing in the next episode where we're going to need to use this, we're falling through. And to explain to anyone who doesn't understand what that is, if we called adjust stat for a health, what we're actually going to do is execute all of this code here until we hit that break. So we would have our health change, our hunger change, our stamina change, and our thirst change, all by the amount we intended to change health. And doing that, I also see we have a fall through up here, again, courtesy of IntelliSense. So something to be cognizant of or pay attention to. Sometimes you're going to write code quite some time ago, because our stat line was one of the very first things we created, and you're going to miss code. In this case, we just want to quickly fix this and throw in some break commands after. Actually, we don't even need to use break there. We're not wanting to execute any further code, so we can just put a return instead. And then this guarantees we fixed our issue. And you notice these will slowly, it's saying an unannotated fall through. And the reason for that, I'll explain. You can have, I believe it's fall through. It's been a while since I've had to use it. It's something like that. You put that through, you put a little attribute on there, and it will say, yes, I intend for this to fall through. But we don't actually want that. So I'm just going to throw these, and do we want breaks on this one? Yes, because this is a for loop. So finish that one off. And again, these are going to stay until IntelliSense hasn't updated. We do also have an error, though. It failed. Pickup actor, use of undefined item, item base. Did I not add that in there? No, I didn't. So that is on me. So we'll just grab our item base include, and we'll throw that in there as well. So just with that, like I said, I've said in numerous other episodes, I do like to include my mistakes that I make and fixing them, because chances are you're going to make similar mistakes yourself. So with that, though, let's try another build. Let's see if this one's going to take a little time. It's only 5 this time, which isn't bad. How long did clear it is. But say, how long did the last run take? I didn't look. But, so pickup actor, stat line component, both of those are compiling. Everything's good this time. So we're going to launch the editor. Pull that over, and this should be pretty quick because I had launched it earlier. Oh, I've seen an error in there. Is that the same one we're getting? The uninitialized variables. Yeah, I'm going to do some off-camera research to figure out how to initialize those, because they're pointers. Anyway, so we're going to go into the editor, and we are going to open, actually let's pull the content browser over. We're going to go into our project file within the main content, blueprints, into our dev folder, and we have our log. So we're going to expand that, or open that, not expand it. And you can see we don't have an inventory item for it yet. So we're going to put BP log. Item count, interaction text is going to be pickup log. Pick up log. Save that. Well, sorry, compile and save that. And I'm going to move this one out of the way. And then we're going to go look at our items. Junk items. Log. Now, for anyone who's missed the other episodes, the reason I'm calling these junk items is they themselves do not directly have a use. Like, you're not going to have your player eat a log. Well, at least in my game, I'm not. If you have something like Timberborn, it's a beaver game, that, yes, you're probably going to eat logs. However, so just wanted to go through in here and quickly say, take a look to make sure we've got everything. We have the item name as a log, a wooden log. We've given it an icon. Max stack size is 10. Current stack size is obviously 1. That's the default. It doesn't have resource tags because this in itself is going to be treated as a resource item, at least for the time being. but you would want to say potentially add something like planks or wood, like a broken down item. And that's what the whole purpose of the resource tags are for, is to indicate what the item will break down into and the quantities. Then we have a world mesh, and this is just a reference to if the player drops the item, what should it spawn for the static mesh of the world that you can then pick up subsequently. And then finally we have the item weight, which in this case is 25. So we're just going to compile and save that because I made some changes even though I removed them. So we're going to move this out of the way, move our content browser out of the way, and hop into our play-in editor. And quickly we'll just see inventory is up, nothing there though. Pick up our mushroom just to make sure. Inventory, yep. Okay, we're going to go over and start harvesting our trees. Now you may have noticed that the interaction requirements it's at the character's hips. One thing you have to keep in mind is I do plan on changing this to a first-person perspective. I just haven't got there yet. Mainly because I'm trying to get most of the primary logic sorted out first. Switch it over to a first-person camera, and most of this behavior is going to continue to be the same. So, anyway, so we're going to pick that up, and you can see that was destroyed, and we have, oh, we've got an issue there. Our mushroom disappeared. So that is going to be down to, well, first of all, there's two things. One, I was incorrect. This works. So that's not needed. But we do have an issue with our inventory component. So let's open that up. And what did we say? Where's our pickup actor? Oh, it's just in there. Nope, harvest actor, pickup actor. Add item to top. So we want to add item to top. Where are you? I'm going to throw that in there. We're going to hop back into the editor. We're going to run another play-in editor. So this is going to hit the breakpoint as soon as we pick up the mushroom. We're just going to continue. We're not worried about that. And we're going to head over and try and grab our log, and I want to see what's happening here. Because this is the concern I had, where it would replace instead of add. So I'm going to hit F. So is item valid? Yes. Item weight, that should be 25. Yep. Inventory contents is 1 and 0. Okay, that's good. Okay, so maybe that's our UI that's broken then. Let's just check our inventory. Okay, so you can see here, it did actually do what I wanted. It put the log at index 0. I'm going to go pick up the other one. We should have 3 items in there then. Let's continue that. We don't need to worry about it. Yeah. Oh, and we still have that same issue with, we're getting the pickup log text is staying there, even though it doesn't need to be. Anyway, so you can see we have 3 items in our inventory. We have an index of issue. Let's go to our UI, because now that we have 3, we're seeing 2. So basic HUD. Oh, sorry. Let me pull this over so you can see it. We're going to go into our graph, and we're going to throw a breakpoint here. I'm just going to quickly trigger that. Okay, so we are clearing the children. That removes everything. We should have... We're only getting 2 items. So that tells me it's not here that the issue is. It is... Where is our inventory? Inventory component. this is the issue right here. So what we're going to do is change that to an equals, so it's less than or equal to. We're going to hop back into the editor. I'm just going to continue. I'm going to stop debug, play in editor mode, or simulation. And we're going to throw a live code update. All right, that's finished. So we're going to repeat what we were just doing. We're going to pick up 3 items. Actually, because we know that's that one there. We don't need to worry about that breakpoint. So I'm going to go pick up 3 items. Let's pick up 3 logs. Actually, 4 logs, because that'll be our inventory. Quickly check that here. Go select our inventory. Pick up log. That one worked. Pick up log. That one didn't. Wonder why that didn't. So pick up log. Pick up log. We have a max inventory capacity of 100, so we shouldn't be able to pick up this one. Yeah, it's... I'm not sure if you can hear me tapping away in the keyboard there, but it's not letting me pick it up. So, alright, so now let's go I. Bring this over. I'm going to step through, clear children. This should be 4. No, num 0. Oh. So no, that was throwing, it was correct. So why is that not returning all of them? Okay, we're going to stop this here. So, okay, so that was inventory component over here. So this was correct. So I'm going to throw another breakpoint here. Let's just think. Okay, so for inventory contents dot num, oh, I'm an idiot. I never removed incrementing it within the for loop while also that was from when we were trying, well, I was attempting to do the for auto. I had the, well, I'll just undo what I did. So we're incrementing it twice, so it's only ever going to give us half of what we need. Because, yeah, because that was when this was originally for auto, well, I think that was const auto I had. I had something like that, and we were using the index flag outside of it. And it was, so yeah, that's the reason. I'm an idiot, and I left that code in there. So again, big proof and a big example, I should say, as to why you want to step through your code. I don't want to say every single code change you make, because you're going to spend more time, particularly with something like Unreal Engine, where you got to start the engine, play an editor, things like that. But you want to try and step through your code as reasonably often as possible, just simply because you're going to run into these silly mistakes like I had made there, where I left an index of operator, an index incrementation operator in there when I didn't need to. So, okay, so pick up log. Okay, I'm going to leave that one. Is it the second time we do this? Yeah, it's... This is weird. It's because there's still one within the... I think that's why. So, can't pick that one up. Hopefully you guys can hear that keyboard. So we're going to go to character just to make sure we have 4 things in our inventory. I'm going to try and fix that pickup logic as well, the text logic. Yep, we got our 4 there. Our weight is 100. Now let's hit I. Step through here, and num is 0. Oh, because we have a breakpoint there. Because I'm special. Hit that. There we go. Num is 4. So you can see we have 4 logs. So we're just going to continue. We don't need to have that there. And you can see by the way the inventory code was written, we're not auto stacking. Everything is going in individually. So I'm going to do one more thing here. We're going to go play, and I want to show, just to prove that they're going in top to bottom, the order, sorry, bottom to top, the order that they're picked up. I'm going to pick up 2 logs. I'm going to run back over, pick up the mushroom, and I really need to figure out why that pickup text is staying there. Pick up another log. So based on the way my logic is, the inventory should present as log, mushroom, log, log. Oh, I left the breakpoint in there in the blueprint, which you don't care about. So as you can see, log, mushroom, log, log. Now, you can also see there's some UI issues here because we're using some dynamic sizes. So the inventory widgets, actually I'm going to fix those up. So let's, actually here's, close that, save. Oh, still another breakpoint I don't need. That's from when we were checking the inventory component. I'm going to drop out, and I'm just going to open up that widget. So here, stack box, we can't add any color to it, but what we're going to do is wrap with a border. I'm going to select our border. Content color and opacity, we don't want to change. Our brush, however, I'm going to set you to black. So compile and save, and you can see here we now have a black background, our icon, our text. Now launch this, let's hit 9 to load. Again, breakpoints we don't need. So it should be over here. We should hit I, and you can see our log inventory widgets are not the same size as our mushroom, and actually our mushroom is also too small for the text. So those are the sort of things you're going to come across as you're debugging stuff, stepping through. You're going to like, oh this, oh that. As I mentioned before, I'm not a UI person. My UI is going to look janky. I will just say that, because the UI is the last thing I'm ever going to worry about, because making the UI look pretty, in my opinion, and I know there's going to be front-end people out there who are going to want to burn me for this one, but in my opinion, the UI is the easiest portion to do, because you're taking all of your back-end logic, you have everything you need there, and you're turning it into just a visual representation. Yet you may need more information from the back-end side of things. Like I may find out down the line I need to write some custom blueprint widget code for how long is the item name. So like that unknown mushroom, okay, it's this number of characters, and it's a total of 800 pixels, things like that. So from that though, I am actually going to call things here. It's a spot on 30-minute episode pretty much. From that, hopefully you guys have got some understanding of the inventory system. Next episode, I'm not sure what I'm going to move on to next episode. I might actually expand, and actually next episode we're going to set it up, to where the game is not still functioning in the background. Your player control stops. But because I want to, again, as I mentioned in other episodes, have a survival game, I want it to be a case of the game isn't paused. The only time my game is going to be paused is if you go into the what is normally called your escape menu. So with that, folks, though, thank you for watching. As always, any comments, questions, concerns, suggestions, please feel free to leave them in the comments. I've been responding to all the ones I get, and I continue to try to do so. Thanks again, and I will see you in the next episode. Hey there, folks. So, last episode we set up our log pickup actor to be added to the inventory, and we did some inventory work for getting things to show in the UI. One issue we had, well, and it's not really an issue, it was an intended and known limitation of how it was implemented, is we did not have the ability to, or we still had, I should say, the ability to move the character around while the UI was open for the inventory. And that's not something you want. Now, this episode we're going to focus on fixing that, and well, not fixing, but addressing that, and then also potentially going through and adding in or working on the inventory widgets so they actually look a little better. So, first thing we're going to do though is we're going to work on getting the inventory to, getting the player character to move or not move while the inventory is open. So doing that, the first thing we need to do is add in a U function, blueprint native event, void toggle player inventory with a const bool reference input of b show inventory. And then we want the exact same thing as we've done before. We need it with the implementation. And I'm actually just going to copy paste this so that I have the actually no, we don't need the input parameter, sorry. But anyway, so I just copied the implementation so we had the correct spelling there. So we're going to create the definition for this. Now we also want to add in a variable that we're going to use to determine whether or not we need to show the inventory. And this is going to be U property visible anywhere. It helps if I spell property right. U property visible anywhere, blueprint read only. We don't need it to be saved or anything like that. Bool b inventory is shown equals false. Now, what we're going to be doing is, we need the meta tag. Because it is a private variable. So what we're going to be doing just in our, first of all, I'm a little scatterbrained. We also need to add the action. Currently it's just hard bound to the letter I. We want it to be a bindable action. So I'm just going to copy all of this, throw that down, and inventory action. All right. So anyways, over here, I just forgot what I named the variable. Wow. Inventory is shown. So b inventory is shown equals not inventory is shown. This is just being used as a toggle. And then following that, we're going to be calling the blueprint version. And the reason being is the inventory is a UI aspect, and I've found UI, it's far better to do that through blueprints than it is through code. Personal opinion. You may find UI is better to do in code. I'm not so sure on that myself. But anyways, we then need to add in the actual binding. So enhanced input component, bind action, inventory action, e trigger event complete this, and then we want a tf player character, and we want to make sure we're calling the implementation, not the blueprint version of it. And the reason being is we want this function to execute this Boolean conversion or flip-flop before we call the UI. Now, so we've got, just make sure we've added the action, we're bind the action, we've created this, and we're assigning that, and that is exposed to blueprints. Blueprint is read-only. All right, so there is a couple of other things we need to do. So one thing to keep in mind when, actually, no, before I go into that, I'm going to show you why. I dislike saying don't do this without providing an explanation. So I'm just going to launch that. I'm just going to pause the recording while the editor builds, and as soon as we're back in the editor, I will come right back. All right, so we're back in the editor now. So what we're going to do here is we're just going to get the new action hooked up. So open the third-party blueprint. And I'm just going to go in here, third-party, third person. Didn't create it. I'm ahead of myself here. We actually need to go into our input actions. We can just duplicate our interact. We want IA inventory. Save that. Back up into our default mappings. Pull this over. We want to add the new mapping in inventory. Save that. Inventory. Type that enough times. And you can see we have our inventory shown. Excuse me. Inventory shown. Oh no, that's the local one. Inventory is shown. Sorry, I'm burp. Minimize that. That's this one here, which we don't actually need anymore. So I'm going to do this and this. I'm actually going to get rid of these. So we want to call override toggle player inventory. Pass that through there, and then B inventory get inventory is shown. Okay, that's that. Compile, save. I believe that's what I need for this first part. Hop back in. I'm just going to hit 9 to load up our previous save game. We hit I. Okay, it's not doing what I want it to do. Oh, I never bound it in the default mapping. That's why. Default mapping. Bind that to the I key. Save. Move that back. Press play. Press 9 to load. Press I. Nothing is happening. Okay, let's hop into our code here in our first-person character. Not first-person, third-person character. Back into the editor. Let's hit I. B inventory shown. Toggle player inventory. Yeah, that goes to that. Okay, so we're good there. Throw that there. Hit I again. Okay, we're hitting that breakpoint. We're going to hit continue. Okay, so we're here. We're showing it is true. Why is it not showing? Do we have an issue with our inventory component? No. All right, so. Oh, I somehow broke a connection in the inventory inventory widget. That's probably from my messing around when I was testing between episodes there. Let's try this again. All of this to show you that there's one other thing we need to do before we can actually wrap up with that. Okay, so we're in here, step into that. Okay, we're now hitting the for each loop because yeah, we had this disconnected here. So I'm just going to hit continue, move this out of the way. Okay, there we go, and we have the inventory. We can see, obviously, we're still able to move around. We're toggling it. Move that breakpoint. So, to not be able to move around, most people, we're in the third person blueprint here. Go to, move this over, set input mode. Most of the time it's going to say, you're going to be told, set input mode UI only. Get player controller. Actually, that's a show cursor. Set that to true. And actually, we can just set that to our inventory show. The problem is with setting it to, and this is what I wanted to show you, setting it to input mode only is, actually, I'm going to throw the break, I need to throw a breakpoint here. So this is within the third party character, throwing a breakpoint on toggle UI. I'm going to play, load, hit I. So we hit this breakpoint once, go through, we show the UI, we show the mouse cursor, and we set the input mode to UI only. So in here, you can see cursors moving around, but I'm not sure if you can hear me tapping away on my I key. It's no longer, like, we're not hitting this breakpoint a second time. The reason being is we are setting it to UI mode only. That is killing our input towards the player character. Now we could go through and add in, let's see, inventory triggered. We could add in some stuff here that is going to call the same thing and eventually like hide it, but I found there's a much easier way, and that's actually why we also added inventory is shown as a boolean. So I'm going to just make sure everything is saved here. I know there's a save all button. I do have trust issues with that, but anyways, we're going to close out of the editor. Back in here in our player character, we can just go through and use okay, on interaction overlap. I'm just trying to find a particular function that's regarding input. Begin play tick data interaction text. All of our inputs are probably up at the top. Yeah, on interact. So what we're going to be putting in here is if b inventory is shown, return. Because we are not pausing the game is the main reason why. Now, I have mentioned in the past how as soon as you're copy and pasting functionality, make a helper function. Well, you can't, well, you could, and actually no, I was about to say you don't really need one here, but no, that you do. So private inner functions, void, bool in inventory. Actually no, inventory shown. Inventory is shown. This is a constant. I keep doing that. Return B is inventory. B inventory is shown. And no, I needed to correct myself on this because the whole reason you want these as a helper function like this is actually I'm renaming this block player no block character input. So what this function is going to be, it's going to be a helper function that is going to be used to determine if we should be blocking these interactions. So I'm just going to copy the function part there. So block character and input. Now, so if we are in the inventory, we don't want the player to be able to hit F to pick something up. We don't want them to be able to toggle sneak. We don't want them to be able to, again, toggle sneak or sprinting. We don't want them to be able to jump. And then now we can just do that for the look action, and the same for the, oh no, we want to put that before, again, just for memory management. We don't want to create a vector 2D that we don't need to. Okay. And the same thing can be added to our line trace. We can just say, look, we're doing something that we don't want to be tracing. So we'll just throw that in there as a return. And that prevents any of this from executing. Now that we've done that, we'll do another build. And I'll explain why. So the reason being is, instead of setting it to UI only, you want it to be UI and game. Because then that's still going to receive your input from your player, and it's also going to allow you to modify things in the UI. And we've added these basically safety catches of the block character input to prevent anything else falling through, so those buttons aren't going to do anything. So let's just launch into the editor. This should launch pretty quickly here. Pull that over. And apparently GitHub's complaining at me. I forgot to close that before I started making changes. But anyway, so now we're just going to open, come on, content browser. Thank you. We're going to open up our third person blueprint. We're going to leave all of this as is. It's this input mode we want to change. So we actually want to go one of two ways, and that's a branch. So we're just going to branch, and we can actually just carry through, because we know our show inventory is being used to show our cursor, and we can use that just to follow through to the next one. So we want set input mode game and UI, set input mode game only. So for showing the cursor, we want game and UI. If we're not, we're wanting it to be game only. And we've passed through a HUD reference there. Compile, save, and we'll give this a shot here. So move the content browser out of the way. I'm going to hit play. I'm going to hit 9 to load up our previous game. We're going to hit I. Now we're toggling the breakpoint here. Currently show inventory is true. We've set that at a code level. So we're telling the UI to display itself. We're saying the cursor to show itself. Okay, now we want to go into set input mode game and UI. I'm just going to continue there. I'll move this out of the way. You can see we're not doing anything in the background, but when I hit I again, we're now actually hitting this a second time, and it's now false because, again, we set that at the code first, turning off the UI, we're hiding the cursor, and we're setting it to game only. Move this out of the way, back to here, and now we're back to being able to process our input. I can't pick anything up there because my inventory is overweight. Hit I, though, you can see I've got, what, 75 in logs and the 2.5 in there. We don't have the extra capacity. So with that, we've gone through and we've set up some basic behavior to allow us to show our inventory, but our character's not going to respond to anything. Actually, I'll just quickly show you that again. So right now, we have nothing in our inventory, but you can... Oh, I've still got that breakpoint on there. Continue. So back here, you can see I'm in the UI. I can't do anything. I'm jumping, trying to move around. Hit I again. I can take control again. Now, we couldn't see anything, obviously, because we didn't have anything in our inventory. Right now, that just doesn't work. But at this point, though, that gives us some basic functionality of what we need. So I'm going to drop out of there. Now, the other thing I said I wanted to do, I'm just going to close my third-person blueprint there, is I wanted to try and fix our UI stuff. So we have our basic HUD and our inventory item. So we want our inventory scroll area. We want it to fill. Now, where is child? Or is it the inventory area? Okay, so we have it as 400 wide. I'm going to change that to 500 wide for a start. And this is where we need to look at our inventory item. So we have our canvas, which we don't have any sizing capacity. We have our border, which we're set to the content fill. Set our anchors to the whole thing, and we'll just see if that makes a difference there. So move this out of the way here. I'm gonna hit play. Hit F to pick up the mushroom and hit I. Well, now we have that issue of, well, we don't have anything other than the text. So we know that this anchor is likely the cause. So we're gonna change that back. Just quickly play. I'm just gonna hit F9 to, oh sorry, 9 to load. Click into the game and hit 9. Hit our inventory. Things are back fine there. So we know the I is the issue. But the anchor is the issue. So I'm trying to figure out. I think it's actually in the HUD that we want to take a look. Creating widget. Fill. No. Margin. Actually, promote to variable. T child. This is just me testing things here. Margin. No. Padding. Set padding. Make. Oh, that's why. So. I can never remember, and this is why I'm not a UI person. I struggle with these quite often. Yeah, no. So we know this hasn't done anything, so I'm just going to get rid of those and get rid of that variable. Compile that. Okay. We want that to be fill. I'm going to leave that on auto, actually. Inventory area. Behavior, orientation, advanced. Actually, it doesn't really matter what orientation. We'll change that to vertical just in case. Well, actually, saying that, we know our inventory area is 500. We're not worried about the height, we're just worried about the width. So I'm actually just going to go 500. Change the padding there to 1. Icon. Yeah. Okay, let's see if that makes a difference. So 9 to load up. No, that didn't. Why is that not? Oh, size to content. That messes with these now. So let's go 0.2. No, not 2.2. Let's see how that looks. That's probably going to look absolutely garish, but well, it's actually not too bad. Obviously need to do some adjustments with the text for the count, like the quantity, but that gives us a better, more at least consistent UI. There's other things I want to do with this, like I want to sort of shift what we currently have off to the right a little bit and then provide what would be your normal character panel on the left to be able to easily manage your equipment. However, I'm not going to be doing that until we actually start getting to the point where we are going to be working with equipables. So I'm just trying to think if there's anything else to clean up right now, because I just wanted to get the last of the inventory, well, as much of the inventory stuff done as possible. Actually, there is one other thing we want to do. So right in the widget, we are going to right click on the stack box, wrap with an overlay. The reason being is we want things to actually want this on top. We're going to add a button. No, I'm not going to do that yet. I'm not sure how I want to do. I was thinking of adding in the use functionality, but I'm not quite ready with that yet. I'm not sure if I want to do a right click menu or how we want to go about that yet. You could add a button like a use and a drop button if you want to have a fairly simple. Actually, I can do that right here. We got a stack box. This is our vertical one, right? Yep. Yep. So I'm going to add a stack. This one should be horizontal. We're going to go button. Text. No, that's the button I want to rename. Use button. Drop button. Use drop. Now we want to obviously change the size of the font on these. I'm going to drop these down to 8 and 8. And then where's our border? We want to expand that ever so slightly, so this is all included there. Compile and save. Actually, do we have an alignment for this? No. So I'm just going to prep things in here. We'll actually get to that next episode. I just realized we're getting close to the 30-minute mark. Now, is this append? No. combine. I can never remember what the format. That's the one I wanted. QNT. No, QT. I'm just going to call count. Okay, let's quickly compile that. We'll save. We'll give this one last quick check to make sure that's working. 9 to load, I to open. Oh, those buttons look horrible, but you can see count is 1. Buttons currently don't do anything. These buttons do look horrible. So, as you can tell, I'm really not a UI person. I'm going to go back to our designer. Just going to... Is it... I thought it was margin. No, apparently it is padding. Padding a 2 on those. And we need to do the same thing we did before. Just drag our border down. And I'm actually going to change this so it's not as in your face with a full black. Let's give that one quick look. One more go. 9 and load. Okay, so it looks a little better. Obviously, it still looks absolutely horrible. It's not as in your face though. So, however, with that, folks, what I'm going to do is I'm going to call the episode here. Next episode, we are going to actually hook in some logic to control whether or not these buttons are visible, and also make them work. That'll tie in some basic logic that we can obviously in the future, once a decision is made on my part as to do I want a context menu with the right click, things like that. Once that's done, we can then go through and expand. But anyways, thanks for watching, folks. As always, if you have any comments, questions, concerns, or suggestions, please feel free to leave them in the comments. I do respond to all of them as best I can. Thanks again, and I will see you in the next episode.